to see how we can send this session inside of our program so we can be able to brute force this username and password. Let's give it a try. If I go to our program and nano the bruteforce.py, first thing that we must specify, as I already said, we're going to need to specify the session, so we need to ask for the user for the cookie value of that session. And they can just read it from the burp suite, just like we did once we covered our Hydra tool. So we can specify right here, enter cookie value. And this can be optional because we don't need it always, just like we didn't need it currently. But if they're brute forcing something within a session, then they must specify this as well. Now, what we can do is inside of our cracking function, right above the if statement, we can write another if statement. So if cookie value is not equal to an empty string, and if it is equal to an empty string, that means that the user doesn't require the cookie value, and in that case it will not send the cookie value and it will just brute force without the session. If it is set to something, then we're going to send the cookie value inside of our request. So in this case, if response, if cookie value is not empty, that means we must send it. So the response will be equal to requests.get, and this time we're using get because inside of this page, our form is using the method get. That's why this time we're using the requests.get. This is something that you want to change depending on the page that you're brute forcing. So requests.get, and the first parameter is going to be the URL. The second parameter, we're going to set our parameters, which we specify like params, and those params are going to be equal to, once again, a dictionary. And that dictionary will be rather the same like this, just a few minor changes we're going to set. So copy this and we're just going to paste it right here. The first change is under the button. So the username and password field are named the same, like in our last page. As we can see right here, inside of the form, the name for the username is just username and the name for the password is password. But the login is not the same. We got the value for login to be login and the name for login to also be login. So we can set it like this, login and then 2 dots and once again login. And the last parameter to this function, or the last argument to this function, is going to be cookies that are equal to a dictionary of cookie value, 2 dots and then cookie value variable. And you can read the name of that field by going to your burp suite, and once I, for example, specify test and test123 as our username and password here, and then I go and find that request inside of our burp suite. Let's find it real quick, and I believe it is this one right here. Yeah, here it is. We can see that the cookie field is named just cookie. That's why we specified right here as cookie between the single quotes, and we paste the cookie value to that field. Once we do all of that, we have all of our parameters to this function, and this seems to not be able to fit inside of my screen, but it doesn't matter, it is there. And all we're left to do right now is create the else statement as well. And the else statement is going to be else. In this case, we don't have the cookie value, so we can just copy this part of code and paste it right here. And now we can delete it from here because we no longer need it. So this program is pretty much only used to brute force the main login page to the DVWA and this brute force page inside of the DVWA. You will need to adjust a few things right here once trying to brute force a different page, such as, for example, the name of the fields, the name of the cookie, and you will also have to adjust whether it is a GET request or a POST request. Everything else, I believe, can stay the same. Now that we got our code ready, let us see whether this works. So if I save this, and I go and try to run this. Let's first of all try once again to brute force the main login page by typing dvwa/login.php. The username is going to be admin, the passwords file is going to be passwords.txt, and the string that occurs is going to be login failed. Cookie is going to be optional, so I'm just going to press enter because I don't need it for the main login page, and it will still manage to find it. But let's see whether it will manage to find the correct username and password if I use the cookie value and if I brute force inside of this session. Let's give it a try. I will enter the page URL, and the page URL is going to be the URL to this page right here, which is this one. So let's copy it, paste it right here, press enter. The username is going to be the same, so it is going to be admin. The passwords file is going to be the same. The string that occurs is not going to be the same, so let's give it a try and see what happens once we send hello as username and hello as password. We get username and/or password incorrect. Now, we don't need to specify this entire statement. We can just specify incorrect. And if it just finds the incorrect, that means we specified the incorrect password. Therefore, it is going to go on to the next one. So let's press enter. And the cookie value is something that we can read from our burp suite. So let's find the request that we use to send hello and hello as username and password. And here it is. All we need to do from here is find the cookie field and copy the cookie value. So security equals high and the PHP session ID is set to a random value. All we need to do is paste that right here and press enter. This will start the brute forcing of our page, and you will notice that this time it goes a little bit slower because we're brute forcing inside of a session. Let's see whether it will manage to find once it gets to the correct username and correct password. Let's give it a few seconds. And here it is. It worked successfully. We found the correct username, which is admin, and the correct password, which is password, and now we can use that to log in to this page. As it says, welcome to the password protected area admin. So we successfully coded a brute forcer. Now you can perform some minor changes to make it even better, such as, for example, importing from term color, import the function colored, and this will allow us to print everything in a different color. For example, let's go down here, and this first print statement we can print like this, colored, and at the end we specify inside of the, for example, let's print this in red. We close two brackets, and once we also find the correct username and password, we can print this in green. So print colored. At the end, we add comma and then green, and we close two brackets. Same thing we can do right here. And let's not forget the colored function right here. So colored. And now if we run this, python3 bruteforcer.py, let's use the regular main page, which is dvwa/login.php. Admin is the account, passwords.txt is the file, and failed is going to be the string that occurs. And it is even better, right now it prints the incorrect passwords in red color, and once it finds the correct username and correct password, it prints it in green. Great. We coded our project, everything works perfectly, just don't forget to change certain values inside of our program once you try this on a different web page. The two main things that you need to keep an eye on is the name of the fields inside of our source code. So you just find the form and you see how the fields are named. Then you use that inside of your dictionary, and the next thing that you need to pay attention to is the method that is used to send these usernames and passwords, whether it is a get method or post method. And at last, you also need to check the name of the button. So this can basically be named anything. That's why you always need to view page source and check it out before running your program. Great. Thank you for watching this coding project. We're getting better and better in Python, and in the next lecture, we're going to create another small project in Python that will be used to brute force directory names inside of a web page. This will be a smaller program than this one, but nonetheless, it will still be a useful program that you will use in your penetration tests. See you in the next video. Welcome back. Let us code our second project for the web application penetration testing section. So, in the previous video, we took a look at how we can create a simple brute forcer that will be able to brute force both of our DVWA login pages. We made the post request, we also made the get request, and we also changed fields accordingly to each one of those pages. Now, as I already mentioned, that program you will need to adjust for every page that you brute force. However, this program that we're going to create right now, which is the directory brute forcer, you won't need to adjust for different pages, it will work for every page. And what a directory brute forcer is, as we already mentioned, it will discover some hidden directories that could possibly be useful to us once performing web application enumeration. So this is something similar as a DERB tool that we covered in web app penetration testing section. So let's get straight into it. I'm going to open the terminal and I'm going to navigate to our desktop and tools directory. Here we got our web app penetration testing directory, and right here inside of this we got our previous project. Let us now nano a program that we can call directories.py. As the previous program, this one is also going to import the requests library. And before we start coding it, let's first think how our program is going to look like. So we're going to ask the user of the program to specify the target URL or the target link. Then we will open a file that has common directory names. We will read from that file, and for each directory name, we're going to perform a request for that page. If we receive a response or if we manage to load that page, that means that directory exists on that page. If we get something like a connection error, that means that page doesn't exist. So this program is really simple. Let's start coding it. And first thing, as we said, is going to be the target URL. This is going to be equal to the input value as usual. And here we can specify something like this. And then enter target URL. What we also want to ask from the user is the file name. So file underscore name is going to be equal to input, enter name of the file containing directories. Okay, so these are the only two things that we need. After we get them, we can open our file like this. So file equals open, and then the first parameter is going to be the file name, which they specify, and the second parameter is going to be opening file for reading. And this is something we already covered, so you should be pretty familiar with how we open files. As soon as we open file, we can start reading different directory names and requesting those pages. So for line in our file, for each and every directory in our file, we're going to first strip that line from any additional characters, and we're going to store that inside of the directory variable. So directory will be equal line.strip. After that, we can create a full URL variable, and the full URL variable will be equal to target URL plus, and then slash, and then plus our directory. So what we are essentially doing right here is, let's say the target inputs a website link or a domain name of google.com. Let's say they input that, and from our file we read the admin directory. Essentially what we are doing right here in this line is we're combining these two like this. So this is how we search a directory on a certain domain. We simply just add a slash and type the directory name. Now that we got the full URL variable, we can perform the same thing from the previous video. Response will be equal to request from full URL. And this request function we don't have. It is not request.get or request.post. It is just the request function that we're going to code right now. So go up here and type define request. this request of course takes the parameter of URL, and what this function should do is it should try to connect to that page that we're looking for, and if it doesn't manage to connect, we're just going to pass. So how can we do this? Well, we can type try, and then we can try to return from this function requests.get. And the reason why we are returning is because we're going to store the response inside of this response variable. So we're essentially returning requests.get, and then let's add HTTP / and plus our URL. So it is going to essentially try to visit our URL. We're just adding it the prefix of HTTP //. So like this, everything should work. If we manage to visit that page, we're going to return the value, and if we don't manage to visit that page, in case of requests.exceptions .connection error, we're just going to pass. And let's not forget to add 2 dots at the end of the except statement. So in this case, we didn't manage to connect, therefore we're just passing, and the return value inside of this response will be nothing, since we're not returning anything. So how can we then check which one managed to connect and which one didn't manage to connect? Well, we can just type the if response statement. And what this if response means is, if there is something in response, then do the following statement. If there is nothing in response, then it won't do anything. So in this case, if we have something in response, that means the try statement worked and we managed to connect to that page. So we're just going to print discovered directory at this path, and we're going to print the full URL. Simple as that. And this is our entire program. Let's go through it once again real fast. So we import the requests library. We ask the user of this program for the target URL. We also ask for the file name. Then we open that file and we read each and every line inside of that file. We strip it from any additional characters and store it inside of the directory variable. Then we create a full URL variable that will be the combination of target URL / and the directory name. Then we request that full URL, and if we manage to connect to, we will return this value inside of the response variable. If we don't manage to connect, this response variable will stay empty, and then at the end we're just checking if there is something in response, print that we discovered the directory at this path. If there is nothing inside of the response, it will not print anything. So let's test our program out. I will save this, and all we need to do is python3 directories.py. We enter the target URL, so let's just go and see what is the IP address of our Metasploitable, and in my case 192.168.1.2. And the name of file containing directories. So we need this file. And luckily, inside of our Kali Linux, if I open a second terminal and I type locate dirb or derb, however you want to pronounce it, we go to the user share and then derb directory, type ls, we will have this word lists directory right here. If we change to that directory, so cd word lists and type ls, we will have a bunch of these txt files. And inside of this common.txt file are common names for different directories. So what we can do is we can copy this common.txt file inside of our home, Mr. Hacker, then desktop, and then tools, and then web app penetration testing directory. Once I go to that directory and type ls, we should have our common.txt inside of the same directory as our directories.py file. So now if I go right here and specify common.txt, press enter, this will go and search for every directory, and we can already see that it is discovering some of them. We got the / directory, the /dev, /index, /php, /phpMyAdmin, and those are all the directories that it manages to find in the main directory of the Metasploitable machine. Now, you can also specify subdirectories if you want. For example, if I run the program again and type 192.168.1.2/dvwa, and I type the same file name, which is common.txt, now it will search for the directories inside of the /dvwa. And we can see it is finding different directories than it found right here. And what you would basically do once performing this type of enumeration is you would try to find something interesting. You would go from each and every subdirectory and try to figure out if there is any interesting directory onto that page that maybe shouldn't be there. For example, if I run our program and I type the IP address /motil-idae, which is the name of one of the directories on our Metasploitable, I press enter, and I also use the common.txt file, it will find a bunch of the directories, but there is a directory that particularly stands out, which is this passwords directory. So we can visit that link, which is 192.168.1.2, and then motil-day/passwords. And it will lead us to this directory, which has this accounts.txt file. If I click on it, well, it seems like we found some file that contains usernames and passwords. We got admin, the password is probably admin pass, and this could be something like a security question and the answer to the security question. So this would be a vulnerability of information disclosure where it gave us some information that we shouldn't have the access to. And we would never know that this passwords directory exists if we didn't run our directories program, which discovered it, and then we visited it and found out that there are accounts, usernames and passwords available for us to read. Okay, great. So we have finished 2 projects successfully. We coded the login brute forcer and the directory brute forcer. So we are officially done with web app penetration testing. And in the next section, we're ready to touch on a subject of man-in-the-middle attack. It is a really interesting attack that we can perform inside of a network, and in the next section we're going to see exactly how we can perform it. See you there. Okay, welcome to the man-in-the-middle section. This is where we can relax a little bit since we covered all the important things that an ethical hacker must know. From scanning, from exploitation, to gaining access with Trojans and web application penetration testing. Now we can lay back and cover something that you won't need that much, but it is a cool attack that allows you to sniff information inside of a local area network. Now, in network penetration testing, this is something that you also want to try. In some networks, there will be protection that blocks this type of attacks. However, to this date, many home networks, schools and company networks don't have this applied. Anyway, before we actually get to run this type of the attack, let's first talk about how does it work. Let's start like this. Now, imagine a home network with many devices. Say we have 2 computers and also our Kali Linux machine inside of that network. Networks also have routers that route their traffic to different websites. And every time that you, for example, communicate with a web page, you do that through your router. You request a web page and a router will forward your request to that server, and when the server sends a response to you, the router will send it to your machine inside of the network. But how does it know which machine to send to? How does it know to who to forward which packet? Well, let's explain it like this. Let's go back to our 3 machines and let's mark them with A, B, and C. All of these machines, including our routers, also have an IP address. So we can say A has 192.168.1.10, B has 192.168.1.5, our Kali Linux machine has 192.168.1.7, and our router has 192.168.1.1. Besides having an IP address, all of these machines also have their MAC address. And these 2 help them communicate with each other over the network. Our router knows who to forward the packets to, thanks to ARP packets and ARP tables. Now, we're going to talk about ARP packets in just a second, but what I want to mention for now is that our router has ARP tables that map every IP address inside of the network with their MAC addresses. Then it uses the machine's MAC address to forward the packet to them. We know by now that MAC addresses are unique, therefore by knowing them, you know the ID of that machine and then you can communicate with that machine. Now, let's explain those ARP packets. What are they and how they allow us to communicate with each other? Well, to explain this, I will remove one machine just for the simplicity. Okay, so there are two types of ARP packets. We have ARP requests and ARP replies, or ARP responses. Now, with requests, we find out what machine has what MAC address, and with ARP replies, we reply to that machine that asks the question with our response. Request would look something like this. Let's say machine A wants to communicate with our Kali Linux machine. To do that, it must know our MAC address, so it sends the ARP request to the broadcast address, which simply means every machine on the network will get that ARP request. And with that ARP request, the machine A asks who has an IP address of 192.168.1.7. And it also tells, send me your MAC address if this is your IP address. In this scenario, our Kali Linux machine receives the request and it gives an answer. It says, I am 192.168.1.7 and here is my MAC address. Now, this is just normal communication in any network. This is how machines and our router figures out to who they should forward a certain packet. However, there are ways that this can be abused. For example, what if I, from my Kali Linux machine, craft an ARP response and send it to machine A saying that I am 192.168.1.1, which is the router. We know that machine A uses router to communicate with the internet, therefore, once we send the machine A an ARP response and tell it that we have an IP address of the router, it will start sending its packets to us instead of the router. For example, let's say machine A wants to visit Facebook. In this case, it would send that Facebook request to us instead of directly sending it to the real router. Well, you might be asking, what now? We just managed to redirect the traffic of machine A to go to us, and now that machine won't be able to access internet because the packets are not being forwarded to Facebook or any other page that they want to visit. Well, not exactly. We can also send an ARP response to the router. In this response, we tell the router that we are the machine A. Now machine A believes that we are the router, and router believes that we are machine A. All we are left to do in this case is forward the packets to keep the connection going. So in this scenario, instead of communication to websites going like this, instead we spoof the network and now the communication is being done like this. In this case, if machine A tries to visit facebook.com, for example, it will send that request to us, which we then forward to the router, and the router forwards it to Facebook. Like this, we can sniff the data if it is unencrypted, and we can also see what websites is machine A visiting. And this communication works both ways. Once Facebook receives machine A request, it sends the response that comes to our router, and then since router is also being spoofed, it thinks that we are machine A and it sends back the response to us. Then we forward the response to machine A, so machine A has no idea that it is being spoofed since it is able to visit any pages and websites. This attack is called man-in-the-middle with the help of ARP spoofing. And of course, when we perform this attack and we spoof our router and targets, their ARP tables will look something like this. The MAC address of machine A changes to our MAC address inside of the router's ARP tables. And that is while it's being spoofed. Once we stop the spoofing, the MAC address changes back to its real MAC address. Okay, great. Now that we know how exactly the attack works, let's mention a few things that we might want to get once performing this attack. The goal of it would most likely be to overall be able to sniff the data going from other machines on the same network. We also want to be able to check out what websites are other machines visiting, and if possible, in case some communication is not encrypted, we would want to sniff passwords if someone tries to log in to some page. Just most of these things depend on which websites are they visiting. Nonetheless, now that we know theory behind the attack, let's see how we can perform it using different tools. See you in the next video. Welcome back. Let's start with our first tool that we're going to use to perform ARP spoofing and man-in-the-middle attack. Now, for this type of the attack, there are many tools out there that you can use to initiate this attack. Some of them are outdated, some of them are already pre-installed in Kali Linux. However, we're going to cover one of the most known tools, which is called BetterCap. It is a little bit harder to use, however, we're just going to cover the basics of it. So let's open up our terminal, and since this tool is not already installed in Kali Linux, we must install it first. And my advice would be for this entire section to run all the tools as a root account. Now you might be asking why? Well, we're going to perform a bunch of different networking things, and some of the networking things could require root privileges. So some of the tools might not run, some of the settings might not work if we run it as a regular user inside of our Kali Linux. So let's real quick enter the root terminal. And to install our BetterCap tool, we can simply type the command apt-get install and then BetterCap. Press enter, press Y once it asks you do you want to continue, and now we're going to wait for the BetterCap installation to finish, and then we're going to enter its framework and perform MITM attack. Okay, it has finished. Now, there are two ways that we can run this attack. We can run it as a command by specifying a file that contains all of the BetterCap commands that we want to run, or we can run it inside of the framework. Now, for the first try, we're going to just type BetterCap to open the framework, and we're going to experiment with different commands in order to run this attack. And then after this, we're going to see how we can run it just from a terminal in a one-line command. Okay, so once you type BetterCap inside of your terminal, it will open the BetterCap program, it will tell you which version it is, and it will also tell us to type help for a list of the commands. So let's type help to see what options do we have, and right here we're going to see a bunch of available services that we can run with BetterCap. Most of these services are not going to run, as it says right here not running, and the only one that you will see running is events.stream. Now, you might already start to notice something interesting for us, such as for example this ARP spoof. We talked about ARP spoof in the previous video, and we know that this is the base of our man-in-the-middle attack. However, before we get to it, let's go a little bit up and check out the help menu. So these are the commands that we can use with BetterCap. We can type help and then some module name in order to print out more information about that specific module. We can also active, quit, sleep for a certain amount of seconds. We can set value the same way that we do inside of our MSF console. If you remember, once we set values for certain payloads, we do that using this command. So we can assume that this is something similar as an MSF console, or at least it has similar options and commands. Now let's go down to these modules, and before we actually get to this ARP spoof module, let us take a look at this net probe module. If I simply just type help and then net.probe, this will give me the help menu and the description of this module. So as it says, it will keep probing for new hosts on the network by sending UDP packets to every possible IP on the subnet. In other words, what this module will do is it will discover all of the online hosts inside of our local area network. So what we can do is we can turn that on to start network host probing in background. Let's run this command as it tells us right here. Copy this, paste it right here, and let's press enter. And we can already see that it managed to discover some of the hosts inside of my network. These are the active IP addresses right here. The next thing that we want to do is we want to type the help menu for the arp.spoof module. So just type help arp.spoof and press enter. And we also get the option as to how we can run this module. But down here we can see some additional options, or as it says right here, parameters for this module. We got arp.spoof.full-duplex, we got arp.spoof.internal, arp.spoof.targets, and arp.spoof.whitelist. In this specific scenario, we're interested in these two, so the full duplex and the targets. The full duplex, if we read the description, if this is set to true, both the targets and the gateway will be attacked, otherwise only the target. And as it says right here, if the router has ARP spoofing protections in place, this will make the attack fail. So in some networks and on some routers, this attack will not work because more and more routers nowadays are starting to implement the ARP spoofing protection. However, if it is not enabled, if the protection is not enabled, then we can perform this attack. So what we must do is we can type set arp.spoof.full-duplex to be equal to true, or just set it to true. Press enter right here. And we also want to set the targets. Now, you can specify the entire subnet or the entire network, or you can do it like I'm going to do. I'm just going to select one target. And the reason why I'm selecting one target is because once you run this on the entire network, there is a lot of information going inside your terminal. And it is going really fast, so you don't even get to read it. Therefore, what I'm going to do for the purposes of this tutorial is I'm going to select the IP address of my Windows 10 machine that we're going to perform the MITM attack on. And then I'm going to set arp.spoof.targets to be equal to that IP address, just like this. Once I do this, I want to start sniffing for the network connections. And we can do that if I go up here. We can see that there is a module called net.sniff. If I type help net.sniff, it will just say that this will sniff packets from the network. And the command that we use to start it is net.sniff. But before we actually start it, let's go and check out the parameters right here. The parameter that we want to use for this attack is net.sniff.local. As it says, if this is true, it will consider packets from to this computer, otherwise it will skip them. Now, once we start the ARP spoof attack, all of the packets from our target machine will go to this computer, therefore this will be able to sniff them. Let's copy this and paste it right here. And what we want to do is we want to set this to true. After we get all of these settings ready, we can type arp.spoof and we can set this on. And we can also type net.sniff on. Press enter, and this will start sniffing packets on our Windows 10 machine. We can also see some of the queries that our Windows machine is making. And if I go and try to visit some web page, we can see that our target machine is querying Facebook. As we can see, the desktop machine initiated the request for www.facebook.com. And this will work for any other website. We can see the requests for twitter.com. And if they were to input a password to an unencrypted website, such as, for example, let's say that they want to connect to our router and go right here, and they type, for example, test and click on login. If I scroll a little bit up, we should manage to find the request where they send the password. And here it is. Here is the request where they send the password. We get the username test and the password is a hashed value. However, we managed to get it nonetheless. It will work for any website that sends unencrypted data. For example, onto this website called vulnweb.com, if I go to first link, which is this one, and I click on login, type username admin and password test, I click on login, and for some reason it seems that it didn't manage to get it. Let's just scroll a little bit up to see whether we can find it, and here it is. Here is the packet that we sent, including the username and the password. We managed to sniff it from our Windows 10 machine. Here is the username admin and the password test. Great. This is one way that you can use Bettercap. Another way that you can use Bettercap is if I exit out of this program, it will automatically start the ARP spoof and it will restore our cache for our one targets. And the way that we can run it with a command is we can just create a file called sniff.cap. And inside of this file, we can type the commands that we typed previously, which is net.probe on. We also want to select arp.spoof.fullduplex to true in order to also spoof the target and the router. And we also want to select arp.spoof.targets to the IP address of our target machine. After that, we set the net.sniff.local to true, which means only sniff the packets that are coming from and to this machine. And then we type arp.spoof on and net.sniff on. These are all of the commands that we must run, so all we need to do is save this in a file called sniff.cap, and then we can run the command bettercap-iface, and iface stands for interface, where we need to specify the interface of our machine. Since on Kali Linux, the only active interface that I have is ETH0. Once I specify that, all I need to specify is another option, which is -caplet, and then the name of the file containing our commands. And this will do everything that we just did automatically. So if I press enter, it will set all of the settings that we did, and it will start sniffing for different connections. For example, if I go right here and try to refresh Facebook, it will sniff that request to Facebook. And this is one way that we can perform man-in-the-middle attack. In the next video, we're going to check out another tool that will allow us to perform this attack that you might actually find a little bit easier to use. So thank you for watching, and I will see you in the next video. Welcome back. Let's cover another tool that we can use for man-in-the-middle attack. And this tool is called similar to the previous tool from the last video. This tool is called Ettercap, just without B. Now, unlike the previous tool, we already have this pre-installed inside of our Kali Linux machine, and this is a graphical interface tool. So it might be a little bit easier for us to run it, and let's give it a try. What we must do first is we must open the terminal, and as I already mentioned in the previous video, let's run all of this with root account. Now, before we actually start running this tool, I want to talk about another thing which is called manual packet forwarding. So sometimes some of the tools will not perform the packet forwarding for you. And if you don't do it yourself, sometimes even after performing the ARP spoofing and the man-in-the-middle attack, your targets will not be able to visit pages because you didn't allow packet forwarding. To always make sure that your packet forwarding is allowed, you can cat out the file at location /proc/sys/net/IPv4 and /IP_forward. Once you cat this file, you will either have a value of 0 or 1 right here. If you have a value of 0, that means the packet forwarding is not enabled, and in that case, you must enable it first. To do that, you can type echo 1 and you echo it into this location. So proc sys net IPv4 and IP_forward. And then you double check to see whether the value of 1 has been added to this file, and it indeed has. Now the packets are allowed to be forwarded. Once you do that, then you can start your tools. So to start the Ettercap tool, all we need to do is to type Ettercap-G. Oops, it says Ettercap not found. Let's give it a try. Maybe it is not installed by default. Let me see. Unable to load Ettercap. Maybe it is lowercase, so if I type it like this. Okay, so now it works. Just make sure that you specify it with lowercase e at the beginning. Then you type Ettercap and then -G for graphical interface. Once you do that, it will open this new window, which is the new version of Ettercap that is a little bit different than in the previous Kali Linux versions. You can enlarge the window, and the first thing that we must do right here is to set up the interface and the sniffing at startup. So you can turn this on. You can select your primary interface in case you're over Kali Linux. It will usually be ETH0. Unless you're running over wireless, then you want to choose a different interface. And once you do all of that, you can click on this check button right here, which says accept, and it will tell you down here started unified sniffing. Now, what I usually like to do is I like to enlarge this lower window a little bit more to see everything better, and then we can experiment with different EtherCap options. The first thing that we must do once performing this attack is to discover all of the hosts on the network. To do that, you can type on this button right here. It will even tell you that this button is used to scan for hosts, and once you click on this, it will automatically scan all 255 hosts on my network, and it will tell me 4 hosts added to the host list. But right here we cannot really see the hosts, so how can we see which hosts are discovered? Well, we can go onto this button right here, click on it, and it will tell us the IP addresses of the hosts and their MAC address. Down here, also these buttons will open: delete host, add to target 1, or add to target 2. And as in the previous video, we're going to perform this attack on our Windows 10 target machine, or in my case, I'm going to perform on my Windows 10 target machine. You can choose whatever machine that you want. Since the IP address of my Windows 10 machine is 192.168.1.7, I'm going to right click on this and add to target 1. To check out whether I successfully added, I can take a look down here, and it does say host and then this IP address added to target 1, but I can also go to these 3 dots, click on targets, and click on current targets, and it will tell me that I have the current target of 192.168.1.7. Once I select my targets, I can start ARP poisoning, and to do that, I click on this right here, which says MITM menu, and we got different types of poisoning, but we're interested in this ARP poisoning. Click on that, and click on OK to start sniffing remote connections. It will tell us down here ARP poisoning victims, group 1, which is the only target that we specify with its MAC address, and the group 2 will be all of the hosts in the list, but we don't have any, so currently we're attacking just the Windows 10 machine. Now there is one thing about this tool: it will not print nearly as much information as the previous BetterCap tool. However, once our target visits a page that sends unencrypted usernames and passwords, it will print that right here. And we can take a look at that by going to our router, as in the previous video, and typing in, for example, admin and then password. If I click on login, down here we will manage to sniff that. As we can see, the HTTP, it will tell us from where did the connection come from, the username is admin, and the password is this. Now this is once again the hashed value of the password, because that is how it is implemented inside of our router. If it was some page that was sending the passwords in plain text, we would be able to see it right here in plain text. Okay, so now that we did the same thing from the previous video, I also want to show you a cool trick that you can check out to see if the target machine is being ARP spoofed. So let's say that we are on our target machine, and this is the machine that is currently being ARP spoofed. How can we check out whether our connection is being sniffed? Well, we can open the command prompt and we can type the command arp-a. And this will give us our ARP cache, or in other words, this will give us the IP addresses of the machines in the local area network and their correspondent MAC addresses. And if we take a look at right here, we can see that all of these IP addresses right here appear to have the same MAC address. And that is not a good sign. Once you see something like this, or if you even see 2 different IP addresses having the same MAC address, that is also not a good sign, and that would most likely mean that a man-in-the-middle attack is being performed, especially if you have an IP address of router having the same MAC address as a different machine on the network. And this is how you can check this out. For example, if I stop this, let's go right here and quit this program, stopping the MITM attack. and closing this. And if I go and run the same command, now you can see different IP addresses have different MAC addresses. And this is how it should be, because the MAC addresses are unique. So one IP address should have one different MAC address, and not like this where we had all of the IP addresses having the same MAC address. Now, in the next video, we're going to take a look at how we can perform this manually using Python 3. We're not going to be sniffing for data, we're just going to see how we can change the MAC address of the router from our Kali Linux machine to appear as the same MAC address from the Kali Linux machine to our Windows 10 machine. Or in other words, if you didn't understand, we're going to spoof the Windows 10 machine with one packet just to change its ARP tables. And we're going to do that using Python 3. So that would be about it for the Ethercap tool. You can experiment with other options as well if you want to, and I will see you in the next video. Welcome back. In this video, we're going to take a look at a cool way that we can actually perform ARP spoofing or ARP poisoning manually. We're going to do that using a huge library that comes with Python 3, and that is called the Scapy library. Now, Scapy allows us to manipulate different networking packets, and we can also send and receive the packets as well. Now, we could do something like this with the help of a socket library, but that would be much harder, because with the help of Scapy we have all of the packets already predefined and we can just craft them to our liking. Now, the same way that you can open Python inside of the terminal, you can also open Scapy inside of the terminal, and this will allow you to write the code line by line. So it will take a few seconds to open this framework, and once it opens up, you will see this Scapy banner, and then you will be able to run the commands right here. Scapy works similarly to Python, so you can use the print statements to print hello world, for example, and it will also run that code as well. However, we're not going to use it for this. We're going to use it to craft packets. For example, there are Ether headers inside of a packet, and to see all of the fields that an Ether header has, we can type ls and then Ether. The same way we can do for the ARP packets. For example, if I type ARP inside of the brackets, it will give me all of the fields that an ARP packet has. And you can do that for any packet that you want. For example, you can also do it for TCP packet, and it will give you all of the fields that the TCP header has. And then you can change each of these fields to your liking. But as I already mentioned, the goal for this video is for us to craft an ARP packet that will poison the ARP cache of Windows 10 machine, and that will tell our Windows 10 machine that we are the router. So how can we do that? Well, first, if you remember, we must know the MAC address of our Windows 10 machine to be able to send the ARP poisoning packet to it. Now, we're not going to cheat and check out the MAC address inside of the command prompt on Windows 10. We're going to get it using Scapy. To do that, we must send an ARP request that we request the MAC address of the Windows 10 machine. To do that, we must also send that request to the broadcast MAC address, which, if you remember, means that every machine on the network will receive that request, and then hopefully our Windows 10 machine will reply with its MAC address. So to do that, let me see if I can use clear command right here. Okay, great, I can use it. To do that, we are going to combine the Ether header that we just checked out with the ARP header or the ARP packet. The reason we need the Ether header is so we can specify the destination MAC field to be the broadcast MAC address. Therefore, our ARP packet will be received by anyone on the network. Let's do that. So let's create a variable called broadcast, and this variable will be equal to Ether header, and the dest field, which is the destination, we can set to the broadcast MAC address, which is for everyone 6 times FF separated by 2 dots. Once you do that, you can close the brackets, and now we got our broadcast packet ready. To check out whether everything is selected correctly, we can type broadcast.show. And this will show all of the fields that we have right here. And you will notice that it will automatically set the other 2 fields. This is the MAC address of our Kali Linux machine, which is the source MAC address because we're sending the packet from our Kali Linux machine, and the destination is to who we're sending the packet. In this case, we're sending the packet to everyone. Now what we must do is we must also create the ARP layer to this packet. And to do that, we can type ls-arp first to check out all of the fields. And we want to target the Windows 10 machine because we want to get its MAC address. So what we must do is we must type the p destination to be equal to the IP address of Windows 10 machine. All the other fields will be set automatically for us, except this hardware destination field, which is the MAC address of our target, which we get from the ARP response. So to craft the ARP layer, we can type ARP layer equals and then ARP, and inside of the brackets we specify the fields that we want to use. In this case, we only specify the p destination to be equal to 192.168.1.7, or you can just specify the IP address of your target machine. Press enter, and before I explain this, I can just type arp.show to show you how the packet looks like. So it will select the hardware source to be our MAC address, it will select the p source to be our IP address, it will select the p destination to be the target's IP address, which in our case is 192.168.1.7, and the hardware destination will be empty because this is the value that we want to get back. This packet is essentially saying, who has 192.168.1.7, give me your MAC address. And to combine this packet with our broadcast layer, we can type entire_packet equals broadcast/ARP layer. And this will put our two layers together. If I type entire_packet.show, you will see we have both the Ethernet layer and the ARP layer. Only thing we must do right now is we must send this packet to our network. We can do that using srp function, and this function takes arguments of entire packet. We can also set the timeout to be 2, and we can set the verbose to be equal to true. Now, this is not something that we want to send. We want to store the response inside of the answer, because if the Windows 10 machine answers, we will have our answer with the Windows 10's MAC address right here in this variable. We also want to only get the answers and not the unanswered packets, and we can do that by specifying right here 0 to select the first element inside of the list. Once we do that, we can press enter, and we get operation not permitted, and that could be because we are not root account. So what I'm going to do is I'm going to run this real quick as root. So I'm just going to write all of the commands that we just did, and I will get back to you as soon as I get to the srp command. Okay, so here we are. Now we made a mistake that I already talked about. We must run all of this as a root account, otherwise some of these commands will not work. And I just typed all of the previous commands that we did, such as setting the broadcast layer, ARP layer, and creating the entire packet. And now we're sending the entire packet with this command, and we're storing the response in the answer variable. So let's press enter, and it will tell us finish sending 1 packets, received 1 packets back, and got 1 answers. Now to get this answer, it's a little bit tricky. So if I type print answer, we will get this response right here. And since all of these are empty, we want to select this other part right here and print just that part. To do that, we can type print answer and then the first element, which will be the answered packets. So in the brackets we specify 0, press enter, and this is our response from the Windows 10 machine. If we take a look at the response right here, we're going to see the MAC address of Windows 10 machine. So we successfully received it with our packet. Now we can either copy it from here and store it in a variable, or we can select it like this. So we're going to print the answer, and from the answer we are selecting the first element, and from the second list we are selecting the second element, and we're going to type .hwsrc. And the reason we are using HWSRC is because this is the field that has the MAC address of our Windows 10 machine, or of our target machine. Then if I print this, it should print just the MAC address, and here it is. And all we need to do right now is copy this and store that in a variable that we can name target MAC address equals, and then our answer with the HW source field. Great. Now we got our target's MAC address and we are ready to craft the malicious ARP packet. So what we can do is we can type something like this. The packet will be equal to ARP packet, and we're going to select the OP field to be equal to 2. Now if you type ls-arp, you're going to see the OP field, and this OP field is simply just asking, are we sending ARP request or ARP reply? Once we select the field to be equal to 2, this means we're sending an ARP response. And remember, to send a malicious ARP packet, it must be an ARP response telling the router that we're Windows 10 machine or something similar to that. Once we set the OP to be equal to 2, we must set the hardware destination to be equal to target_MAC_address. And from here, we are selecting 2 more fields, which are pDestination, to be the IP address of our target. So this simply means that we are sending this packet to our target. And the last part is where we add the malicious thing. Here under the psource, in a real packet, in real communication, we would specify right here the IP address of our Kali Linux machine. But in this case, we want to pretend that we are router. So we're just going to specify the IP address of the router. And this right here is our malicious packet. If I type packet.show, you will see it right here. We have the MAC address of our Kali Linux machine, but we also pretend to be the router. We typed the router's IP address instead of our own. And this packet is being sent to this destination. Now, before I send it, I'm going to open the command prompt on my Windows 10 machine, and I'm going to run the arp-a command from the previous video, just to see how the ARP tables are currently being set. So we can see that the router, which is in my case 192.168.1.1, has this MAC address. Our Kali Linux machine, which is 192.168.1.10, has this MAC address. And you will notice once I send this packet, this IP address, which is our Kali Linux, and the router's IP address will have the same MAC address. And that is an indication that the ARP spoofing attack is taking place at that specific time. So let's send the packet, and to do that we can use the send function. The first argument is going to be the packet, and we can set the verbose to be equal to false, and press enter. If I go back to command prompt and type arp-a again, we can see now router has the same MAC address as our Kali Linux machine right here. So we successfully ARP poisoned the ARP cache of our target machine. Now that we did this, you probably now fully understand how ARP poisoning works. And you can also take a look at different tools online to see if there are some better tools that you can use to perform man-in-the-middle attack. Some of them have more options, some of them have less options, but nonetheless, this is all it is about this attack. You simply just send a malicious ARP packets and redirect the connection to you. So thank you for watching this video, and I will see you in the next section. Welcome to our first bonus section of the course. In this module, we will be covering how to crack a wireless password. Now, this process can be complex because it requires a lot of tools to complete, but besides tools, it also requires something that all of you might not have, and that is a wireless card that supports monitor mode. Now, this is pretty much the reason why this is a bonus section. You need this in order to complete this attack, and not many wireless cards support monitor mode. And what monitor mode allows us to do is to sniff data from access points around us, which then we will use to sniff the hashed password once someone tries to connect to a Wi-Fi. Most of the wireless cards are being ran in managed mode, and managed mode is something you would normally use when you want to use Wi-Fi and surf the internet. However, some wireless cards have this monitor mode option, and I will show you in the next video how you can check whether your wireless card can be put into monitor mode and how to do that. Anyway, let's explain how the attack will work in greater details. So let's say we have a wireless access point, and this wireless access point has 2 devices connected to it. We also have our Kali Linux machine. However, Kali Linux machine isn't connected to the wireless access point. It only has to be close to it to perform this attack. Once we get close to our wireless AP, we turn our wireless card into monitor mode. Once we have it in monitor mode, we will be able to see all of the Wi-Fis around us as well as our target Wi-Fi. Once we choose out of all of those access points which one we want to attack, we need to identify two things about that access point. Those two things are the channel on which it runs and its MAC address. Both of these we will be able to see with our tools that we will use. Now, channel is just a digit and we already know what MAC address is. Right now that we got our information that we need, the next step is to capture the password. But how can we do that? For this, a device must try to connect to that wireless access point, right? Correct. And once it tries to connect, it will initiate 4 different steps, also known as a 4-way handshake, between the device and the access point. In those 4 steps, it sends the hashed password value to the access point, and that is what we want to sniff. However, it could be a long time until someone tries to connect to that Wi-Fi. So, are we going to just sit there and wait for someone to connect? Well, of course not. We're going to perform a different type of the attack to kick everyone off of the Wi-Fi, and that is called the authentication attack. Once we send the deauthentication packets, this will disconnect every device that was previously connected to that access point. The goal of this happens once we stop deauthenticating. Then, those devices that got kicked off Wi-Fi a few seconds ago will try to reconnect back to that access point. And all that time, we will be sniffing for that 4-way handshake with our password key. And as soon as they connect, we will get that password value that we want. After this point, we no longer need to be close to that Wi-Fi access point. We can go on the other side of the world in order to crack that password. Now you might be asking, how? Well, we wrote the hashed password inside of a file. Therefore, it is on our PC, right? After this, all we need is a little bit of luck that the password is easy and not complex, and then we use that hashed password that we sniffed, and we throw it into different tools that can help us crack this password. Most known tools used for this are AirCrack and Hashcat. AirCrack uses CPU power or processor power to crack the password, while Hashcat can use both CPU or processor power and your graphics card power, and it can sometimes crack a lot faster than AirCrack. Now, the average speed of cracking passwords with these programs, depending on what CPU and GPU you have, would be around 300 to 100,000. And yes, of course, we're talking about 300 to 100,000 passwords per second. So this is a completely different story than, for example, brute forcing web login page or SSH or something similar. This is a lot faster. Now, of course, since we're running a virtual machine, the speed will be significantly lower, but compared to previous brute force attacks that we did, it will still be really fast. If the password is not complex and we manage to crack it, then you guessed it. We can connect to that wireless access point. And if we want, we can attack the devices inside that network with all the previous attacks that we learned. But that is completely up to you, what you do after you gain access to the Wi-Fi. So now that we know how all of this works, let's see the practical side of it and let's crack a wireless access point. See you in the next video. Welcome back. And let's start with wireless hacking attack. So you will notice that I'm currently not on my Kali Linux machine. I'm currently using my laptop because my laptop has a wireless card that supports monitor mode. And in this video, I will show you real quick how you can put your wireless card into monitor mode, and if it works, that means it supports the monitor mode. If it doesn't work, well, that means your wireless card doesn't support monitor mode. However, in the resources, I will leave some of the wireless cards that are used for wireless hacking, and all of them support monitor mode. So if you really want to perform this attack, you can check them out online and you can get yourself a wireless card. Now, before I actually do anything, I'm going to zoom all of this in so we can see everything better. And the first thing that you must do is you must type the command ifconfig. And since this is also Linux, all of the commands inside of the terminal will work the same as we learned. And now here we can see we got three different interfaces. I got the ENO1, the loopback interface, and WLO1. And this is my wireless card. It is called WLO1, and for you it might be called something different. However, the process of putting it in monitor mode is rather the same. First thing that you want to do is you want to type iwconfig to figure out what is your wireless card. Just to make sure, I typed iwconfig and it told me that WLO1 is my wireless card. It is connected to this ESSID, and what ESSID means is just the name of the wireless that it is currently connected to. And here we can see the mode that I talked about. You will notice that this wireless card is currently in managed mode, and this is the regular mode that all of the wireless cards are once you try to connect to a wireless access point. To put it in the monitor mode, what you want to do is you want to type ifconfig, then the name of your wireless interface, which in my case is WLO1, for you it might be different, and you want to put it down. How do you do that? Well, you simply just type ifconfig WLO1 down. You won't get any output, however the next command that you want to run is iwconfig WLO1 and then mode monitor. You press enter, and the third and last command is putting the ifconfig up. So you just type ifconfig WLO and then up. Now your card should be in monitor mode. To double check it, you can type iwconfig, and now you can see that WLO1 is in monitor mode. This is how you can put your card inside of the monitor mode. And you will notice as soon as you do that, sometimes you might get disconnected from the internet. You will not be able to access the internet inside of the monitor mode. And sometimes this will by default go back to the managed mode, so if I type ifconfig or iwconfig once again, you will notice that it went back to managed mode. So sometimes you might want to perform this multiple times until you actually get it in monitor mode. However, this is how you put it, and in the next video, let's get straight into getting our hashed password from our target wireless access point. See you there. Welcome back. So we saw how we can put our wireless card in monitor mode, but right now let's get to the real attack. So the steps go like this. We want to put our card in monitor mode. We then want to sniff all of the information around us. Then out of all of the wireless access points, we must pick the one that we want to attack. And in this video, I will be attacking my own wireless access point because attacking anyone else's would be illegal. So we'll be attacking my access point. You can attack yours if you're still following this section. And once we choose our target, we need to check out the channel on which the target is running on and the MAC address which the target access point has. Then we must run our sniffing program, and simultaneously while running that sniffing program, we must run our deauthentication attack. Then we can deauthenticate the devices on that access point for a few seconds, and once we stop deauthenticating, we should be able to sniff the 4-way handshake with the hashed value of the password. Then we can move on to the Kali Linux machine, and there we're going to try to crack that password. Okay, there are a lot of steps in front of us, so let's get straight into it. So what I'm going to do is I'm going to put my wireless card in monitor mode, as I did in the previous video. Nothing really to explain too much here. And the next command that I want to run right after it is airmon-ng check WLO1, which is my wireless interface. Now this program is something that you have inside of your Kali Linux machine, so you shouldn't have problem running this. The wireless interface is something that you want to change to the name of your wireless interface, and once you set the entire command, you can click enter. It will tell you that it found 5 processes that could cause some trouble. Now this means that if we run into any problems during our process of gathering the 4-way handshake with the password, it could be due to these processes still running. So we're just not going to risk that, and we're going to kill all of those processes straight away. How can we do that? Well, we can type ermon -ng and then check and then kill. Once you type this, press enter. It will also tell you that it found 5 processes, but down here it will also tell you that it is killing all those processes. So now we shouldn't have any problem running our other tools. Once you do that, what you want to check is whether your wireless card is still in monitor mode, and since it sometimes turns back to manage mode, you must put it once again into the monitor mode after performing the ermon-ng command. After you put it back to monitor mode, the next command that we want to run is arrowdump-ng and then the interface that is currently in the monitor mode. Since WLO1 is inside of the monitor mode for me, I will press enter right here, and this will start sniffing all of the information around me. Let me enlarge this terminal, and we're going to be able to see all of the wireless access points that are around me. These are the names of the wireless access points under the column ESSID. The authentication and the cipher and the encryption is type of the protection that the wireless access point has, so you can see most of them will have WPA2, which is currently the highest protection they can possibly get. CH right here is something that we want to remember because this CH column is actually the channel, and you remember channel is one of the 2 things that we must need in order to perform this attack. The data can tell us if the access point is active currently or if it has some devices connected to it that are browsing the internet, while the beacons would usually tell us the same thing. However, the PWR right here can tell us how far away is the access point. So the lower the number, the closer the access point is to you. And sometimes if you choose an access point that is far, far away, this attack might not work. You have to be really close to the target in order for this to work. However, you do not have to be connected to the target. As you can see right now, I have no access to the internet, I am not connected to any access point, and I will be targeting this access point right here, called Takmichar. This is my wireless access point, therefore I will be targeting that one. Now, remember that we need to remember 2 things. So the channel for my access point is 2. And by the way, once you choose your target, feel free to Ctrl+C this, because sometimes this screen knows to move and you cannot really copy and paste different things that you need. So I have chosen this target right here, and I need to remember the channel, which is 2, and the MAC address. Now the channel is easy to remember, so therefore I'm just going to copy the MAC address right here, and then we need to start the sniffing process again. However, we're going to write information inside of a file. For this, we're only going to sniff 1 access point information, and to do that, we must specify the channel and the MAC address. So we start the command the same, with arrowdump-ng, then we use -c command for the channel, and we specify the channel number. In my case, that is 2. And arrowdump is also a program that you have pre-installed in Kali Linux, so all of these programs that we use you will already have in your Kali Linux machine. If you don't, or if you're using some other machine to perform this, I will link in the resources how you can download all of these tools. It is pretty simple, so you shouldn't have any problem downloading them. Nonetheless, let's get back to our command. So we got arrowdump-ng, then -c for the channel. We specify channel number 2. For you, it might be different channel. And after that, we use --bssid. And what bssid is simply the MAC address, since we can see that the column where MAC addresses are is called bssid. So after this, we must paste our MAC address to our target wireless access point, and the last parameter to this command is going to be -w option. And this -w option simply stands for the file name that we're going to write all of this in. So let's call this the wireless access point name in capital _test. This is going to be our file name. And by the way, also once running this command, remember in which destination are you running the command, because that is where it's going to save your files. I'm saving this as takmichar_test, and the last thing that we must specify is the wireless interface, which is currently in monitor mode. For me, that is WLO1. You specify your wireless interface in monitor mode, and once you craft this entire command, you can press enter. And you will notice right here, it will only sniff for this specific wireless access point. We can see the name right here under the ESID, and we can see its MAC address. What also we can see are the devices that are currently connected to this access point. And at the moment, it only has 2 of them. Now what I'm going to do is I'm going to connect to the wireless access point over my mobile phone. And you can see that we already managed to capture the WPA handshake, which is all that we need in order to be able to crack the password. However, we're going to try to do that again, just by performing the deauthentication attack. Because we cannot really wait for someone to randomly connect to our access point. We must disconnect everyone from that access point. And to do that, I'm going to enter the root terminal. And I will enlarge this, of course, so you can see everything better. And the command that we must use to actually deauthenticate someone is using the AirPlay-ng tool. So it is spelled like this, and the options that it takes is -0, and then space and 0 once again. This means it will send the authentication packets indefinitely until we Control-C the program, and then it will stop deauthenticating. So what I advise you to do, if you're following this attack, is connect your mobile phone to the access point, and you will notice as soon as we start running this command, your mobile phone will get disconnected from that wireless access point. So once you type -0 and then 0, the next parameter is -a, and after -a comes the MAC address of the wireless access point. At the end, we only specify the wireless interface in the monitor mode, and we can start deauthenticating. And if I take a look at my phone, I am instantly being disconnected from this wireless access point. And if I go to settings and try to connect back, it will not work. Nobody will be able to connect to this wireless access point as long as I am running this attack. But you only want to run this for a few seconds. And once you run it for a few seconds, everyone will be disconnected. Then you Control-C. And here, in just a few seconds, we will be catching WPA2 handshakes with the hashed value of the password. From my phone, I already established connection to the wireless access point. And once you do that, in the upper right corner, you should see this WPA handshake. And as soon as you see that, you can Control-C this program. You got everything that you need. You got the 4-way handshake, and inside of that 4-way handshake is the password that you need. Once you finish all of this, you will notice that you got 4 different files on your desktop. As you can see, 1, 2, 3, and 4. And you actually only need 1 out of these 4 files, and this is the .cap file. All of the other 3 you don't need for this attack, so you can just save the .cap file and you can delete the others. Once you have the .cap file, inside of this file is our 4-way handshake, and then in the next video we're going to use different tools to extract the hash password from this .cap file, and then we're going to use massive word lists to try to crack this password from this file. But for this, I'm going to switch to my Kali Linux machine, so we can go back to our normal environment, since I no longer need to run any program on my laptop. See you in the next video. Welcome back to our Kali Linux machine. So we captured our password from the wireless access point. We performed the deauthentication attack, we kicked everyone off of the internet, and then when we stopped the deauthentication attack and someone tried to connect back, we captured the 4-way handshake into one of these files. And I transferred them to my Kali Linux desktop. And do you remember which one of them is important? Only this .cap file. All of the other 3 we don't need. Now you can delete them if you want to, I'm just going to move them on the side. And this is the file that we're going to use for both ways of cracking the password. Now open up your terminal first, and unlike any other brute force attack that we previously did with small password lists of tens or hundreds or thousands of passwords, this one is going to be a huge password list. This password list contains over 10 million unique passwords, and it is on our Kali Linux machine. So how can we find it? Well, you can type the command locate and then rockyou.txt. This is the name of the password list. And we will see that it is currently in this location right here. So /user/share/wordlists and rockyou.txt.gz. Let's go to that directory. And let's copy rockyou.txt.gz to home, Mr. Hacker, and then desktop. Let's have both of the files at the same location. Now let's go back, and you will notice that this file has this .gz extension. This means we have to unzip it first, because this is a zipped file. Since it has .gz extension, we can unzip it using gzip tool. And to do that, we type gzip and then -d and then the file name. If I press enter, you will see that this file is so big that it actually takes a couple of seconds for it to get unzipped. And if I were to actually try to cat that file, well, you will see this will go on forever and ever. Now I can Control-C this and nano that file if I want to make some changes or add some passwords, and you will also see that this takes a couple of seconds as well due to file being so big. Down here we can see it has 14 million passwords. All of these are some simple passwords that could occur in most of the cases when someone has a simple password, especially for wireless access points. For example, here is 123456789, we got password, princess, rockyou, and some names right here. Basically, these are just some usual words that occur in passwords. Now, to crack this, now that we got both of these files right here, we're going to use the .cap file from our desktop and the rockyou.txt word list. We're going to combine that with a tool called aircrack. Aircrack is also pre-installed in Kali Linux, so you just type aircrack-ng. And to crack the password, all we need to do is type -w and then the password list name. In our case, this is rockyou.txt. And after it comes the name of the .cap file. So I'm just going to type the name of the file and then .cap. This is the entire command. If I press enter, you will see it will start cracking our password. Down here you can see the different phrases that it uses, such as current phrase. This is the current password that it is currently trying to guess. And here we can see the progress of all of the passwords. So by the time that I started this program, it already managed to scan over 10,000 passwords and compare them with our hashed password. The speed you get right here in brackets, which is currently almost 400 passwords per second. And here you get the total number of passwords that have to be tested. The time left is at this current speed, how much time you have left to go through all of these passwords. And here you get the percentage of the entire password list, which we're currently at 0.15%. Now, of course, we're not going to be waiting for this. I can just go and check out whether the password is in this password list. Or what I'm going to do right now for the purposes of this tutorial is I'm going to manually add that password to our password list. So I'm going to nano the rockyou.txt and I'm going to scroll a little bit down to, for example, 400 or 500 password, and there I'm going to write the correct password to my wireless access point. And we want to see whether our program will be able to find it as the correct password with that speed of 400 passwords per second. So I'm going to stop right here, and let's type a new line, and here I'm going to add the correct password to my wireless access point, and it is this one right here. Now you should do the same thing, just scroll a little bit down through this password list and just write your password somewhere in the list. And you will notice that it will manage to find this in less than 1 second. So let's save this first, Ctrl O. It will write this to the file, and then we press Ctrl X to exit. The next thing that we want to do is we want to run this exact same command, just this time we know that we have the correct password in that list. Let's press Enter. And here it is. It managed to find the password in 1 second. You will notice as soon as it finds the password, it will stop the execution of the program, and it will print it right here. Key found, and in the brackets will be the correct password to that wireless access point. It scanned about 492 passwords out of 10 million, and in less than 1 second, it found the correct password. How cool is this? And keep in mind that this is the speed of us running this from a virtual machine. For example, once I test this program on my laptop, it has a speed of 3,000 to 4,000 passwords per second. And in the next video, we're going to see how we can increase the cracking speed even more. So with Hashcat, which is the program that we will cover in the next video, we're actually cracking the passwords with GPU. And here, we're cracking the passwords with our processor. And cracking with GPU is much faster, therefore we should have a higher speed once performing the cracking with our Hashcat program. Nonetheless, more about that in the next video. See you there. Welcome back. So we have cracked the password with our AirCrack tool. We noticed that the speed was around 300 to 400 keys or passwords per second. We saw that it works once we added the correct password to our file, and we also saw some of the other options such as time left, the percentage, and the amount of passwords that have been tested. But right now, let's see how we can crack the password even faster using the Hashcat tool. So let me clear the screen from the previous video, and what I got on my desktop right now is I got the rockyou.txt password list, and I got the rockyou.txt with our correct password. Now these are the two exact same lists from the previous video, just this one contains the correct password for our wireless access point. We're going to run the first one first, just to see the speed that we get and whether it is any faster than with our AirCrack tool, and then just to prove that it works, we're going to run this list the next. So let's get straight into it. To run the Hashcat help menu, you can simply just type Hashcat. And to get even more options onto how you can use Hashcat, you can type Hashcat and then -- help. And here is the help menu. Down here we got some basic examples of how we can use Hashcat, and if I scroll a little bit up here, we can see all of our available options. And you might be asking, what was the thing that I was scrolling through so much? Well, these are just different types of password hashes that you can crack. You have SHA-1, SHA-2, SHA-512, you got Gitsak, you got zip hash, you got MD5, different types of MD5 hashes with salt, without salt. That goes for SHA-1 as well, and for any other password list that we can find. Now, you might be wondering, well, which one are we going to use? In our case, we want to find the WPA password hash, and it will be under these network protocols, and if I go right here, here it is. We want to use the WPA EPOL PBKDF2, and this has a code of 2500. Remember that because that is the number that we're going to specify in our command, And up here, we got something under the -A option, which is called the attack mode. And you simply just specify -A and then different attack mode. Down here at the lower part of the help menu, we get which attack modes we have. Let me just find where it is. I believe it's somewhere around here, and here it is. I believe these are the attack modes. So we got the low, which is specified with 0. Even though it says 1 right here, the low attack mode is specified with 0. And the 4, which is nightmare, is specified with -A3. Now we're going to be running the lowest attack mode, just so we can see how the tool works. So the first thing that we must do is we must type hashcat -A and then the attack mode. We're going to use the lowest one, which is 0, and then -M for the password hash. Remember, the code for the WPA password hash is going to be 2500. After that comes our cap file. But if you were to try to run this program with our .cap file, it would not work. Hashcat works with different cap files. We must convert this cap file to xccapx. How can we do that? Well, we don't have any tool that we can use in our Kali Linux, so we must go and do that online. What I'm going to do is I'm going to open up my Firefox, and I'm just going to search for cap to xccapx converter. Let's wait for this to open a new tab, and type cap to xccap and then x. Press enter. The proxy is refusing connections. This could be due to our burp suite being the proxy, so we're just going to remove it real quick instead of actually opening it. I'm just going to go to network settings and click right here, no proxy. Great, now I will refresh this page, and I'm going to go to this first link right here, which is pcap and cap file converter to xccapx. Let's click on that. Let's select our file. I will click on browse, and I will find my .cap file. Here it is. So I will select that one, and I will click on upload. This will upload the file for me, and as soon as it finishes, I should be able to download the xccapx file that we can use with our hashcat tool. So let's wait for this to finish. And here it is. I can click down here, download my file, and I want to save my file. It will be under here in the download section. As we can see, it has some weird name. Nonetheless, let's copy it to our desktop. For that, I'm going to open another terminal, navigate to downloads, and I'm going to copy our xccapx file to home, Mr. Hacker, and then desktop. Then I can exit this out. And the next thing that we specify right here is that file. So I believe it is called like this. You can rename it if you want to. I'm just going to leave it with this long name. And the last parameter to this function is going to be the word list that we're going to use. In our case, this is going to be rockyou.txt first. This is the list without our password. So let's go through the options once again. The attack mode is going to be the lowest. The -M option specifies which password are we cracking. We're cracking WPA password, so we specify 2500. Then we specified our cap file that is converted for hashcat, and the last thing we specify is the password list. So I'm going to run this. It will tell me that this has been started. It will initialize this backend runtime for our device 1, and it will probably start brute forcing with my CPU. And the reason it does that is probably because we're running this over a virtual machine, so it can only detect the CPU. However, even with CPU cracking, we should still get faster cracking time than with air crack. All we need to do is we need to wait for this to finish, and as soon as that's done, we should start cracking the password. And here it is. It started cracking the password. It will not write anything right here. However, if we type S for status, we can check out what progress it currently has. So we can see some information right here. And anytime you press S, you will see the current progress of this cracking of the password. It will tell us which file are we using to crack, which hash name are we using, The progress and the speed is down here. It says 600 hashes per second, and this is equal to 600 passwords per second. So we can see it is almost double the amount that we had with AirCrack. Down here we can see the progress as to what amount of passwords have we covered from 14 million passwords that we have inside of our program. And we can see we already passed 100,000 passwords. In the candidates, it tells you between which passwords it is currently at. Now you can wait for this to finish. However, even though it is currently at 1%, we're not going to be waiting for all of this to finish. It would take hours. We're just going to quit this with Q command, and then we're going to run the same command just with our correct file. So I'm going to use rawq with password.txt, and I'm going to run this once again. Just make sure that you added the correct password to the password list, and let's see whether it will manage to find it. And keep in mind that if you didn't run this on a virtual machine and you actually used the GPU to brute force the password, you could have up to tens of thousands of passwords per second. And the faster, the better. However, even with this small speed, we managed to find the password while I was talking. So we can see it printed it out right here. Here is the hash, here is the name of the actual wireless access point, and here is the password that it managed to find. So we can see it also did this in less than 1 second. While I talked, we got all of these results outputted. And this is a second option as to how you can crack the password of wireless access points. Now you can use the Hashcat to crack some other passwords as well. We saw that there are a bunch of different hash values that you can use. However, we learned Hashcat through wireless password cracking. Great. And that would be about it for wireless cracking. So thank you for watching this video and this section, and I will see you in the next lecture. Okay, small pause. I just want to notify you that this is an update section and that here we're going to cover Android hacking. So in this small section we will cover the exploitation of the Android devices. Now, even though this is considered mobile hacking, compared to what we already covered by now in Metasploit framework and other tools used for payload creation, Android hacking won't be much different than that. As usual, we will craft the payload with our Kali Linux machine, and we will try to gain access to an Android device. However, you will see that this isn't quite easy or practical in real life as hacking a Windows machine, for example. Why, you might be asking? Well, you will see. There are many steps that target has to perform in order to execute our payload. However, if we make them do it somehow, we will have complete access to their Android device. Another thing is, some of you probably won't have an Android device laying around, so to make this accessible to anyone, we will be downloading and creating an Android virtual machine. That's right, we are simulating a mobile phone with this virtual machine. If you actually have an Android device, feel free to use that one instead to test these payloads out, as that would be the best practice since some of the post-exploitation options won't work on a virtual machine. Once we set up our virtual machine, as mentioned, we will deliver the payload to the target, but what is it that we're after on their device besides just having an access to it and being able to control it? Well, we want to, for example, extract all of the contacts from that mobile phone. We could also read the messages as well as send messages from that phone, and we can check if the device is rooted, and we could, as usual, download and upload files on that system. Those files can be images, applications, and other file types that we want. You can try opening a camera and recording, but most of this stuff we won't be able to do on a virtual machine. However, I will show you how to run those attacks nonetheless, just in case you try gaining access to a real Android device later on. Most of these things we will achieve using our Metasploit framework tool. We will create the payload for Android devices using MSF Venom, and we will catch the connection back with MSF Console. All of this stuff we already know, so we will just get straight into that. But besides all of this, there is one more interesting thing that we will learn for the first time, and that is how we can gain access to a target device that is not on our network. That's right. For now, we only attacked and exploited targets that are on our own local network. But what if we, for example, want to send our payload to the target in a different country, with different router and different devices on its network? Is it the same process? Well, you will see that it isn't actually quite the same. But it's not a hard process either. You can later apply this for any target whatsoever, whether it runs Windows, Linux, or even Android. This will work on all of them in case they are on a different network. Nonetheless, enough of talking, and let's get straight into hacking Android devices. Welcome back. As I already mentioned, in this section, we're going to be using an Android virtual machine in order to make this accessible to everyone. And as you might notice, I already have the Android virtual machine created right here, but right now I'm going to show you how you can do that as well. So the first thing that we need to actually download the Android operating system. In order to do that, we can navigate to this link right here. And on this page, if we scroll a little bit down, we're going to be able to see all of the previous Android versions that came out. Now, we're not going to be downloading the newest one, but let's say that we can use the version 7.1, which is the newest version of the Android 7. And to download it for the VirtualBox, we can click right here and we're going to download the 64-bit version. In just a few seconds, our download will start, and since I already have it downloaded, I'm not going to be waiting for this as it is rather large. It is 600 megabytes. So I'm just going to cancel this, close this page, and once you have it downloaded, you will have a file like this. In order to get the actual virtual machine, you must extract the file, and you will end up with this VDI file. It is the Android x86 7.1 R3, which is the exact version that we downloaded. And if we go to our VirtualBox, in order to actually create the virtual machine, we need to click on New as usual, and you will notice that this creation of virtual machine will be rather different. Because if you just create it like any other virtual machine that we created by now, it might actually not work. And it didn't work for me at the first time. I will show you, of course, what I did in order to get this to work. The first thing that we are going to do is going to name the machine. I'm just going to name it Android 2 since I already have one Android machine. I'm going to select the operating system to be Linux, and I'm going to select the version to be other Linux 64-bit, since we downloaded the 64-bit of Android. Let's click on Next. Here I will select 2 GB of RAM, and I will proceed to the next step. And under the hard disk, we want to click on Use an existing virtual hard disk, and here we want to find our Android version. And here it is. If you don't see it right here, as usual, you can click on Add and then navigate to the directory where you downloaded the version. Select it from there, select it right here, and once you select it, click on Create. Now, before we start this machine, there are a few things that we need to do. First of all, go to Settings. As usual, first let's change the network to Bridged Adapter. Select your name of the adapter right here. The next thing is under the Display Settings, which is the thing that differentiates this installation from the previous virtual machines, is that in case you leave it by default, which is this, it might actually not work. So what I found to work for me is I increased the video memory to 40 megabytes, and I changed the graphics controller from the VM SVGA to VBox SVGA. Now, even though once I change this, it says invalid settings detected, if I leave it on the default one, which is VM SVGA, my machine will not work. But once I changed it to this and clicked on OK, my machine worked. So let's give it a try. Once we set all of those settings there, let's start our machine. Now, if you're running it for the first time, it might actually take a few seconds or minutes in order to boot up, and you don't want to be clicking on anything during this installation. We can remove this and let's enlarge the screen, and you will see this Android pop up, this command-like look like, and don't type anything there, just leave it boot up. Then you will see this Android sign, which means that you're successfully booting into your Android device. Now, in case you're having still problems in actually running this machine, I would advise you to play with display settings, either increase video memory or change the graphics controller. Just try a bunch of different settings right here in order to get this to work. These are the settings that worked for me, but they might not work for you. Nonetheless, let's go back to the Android machine. It will tell us Android is starting, so let's wait for this to finish. And here it is. Here is our Android device. Here you can do pretty much anything that you can do on an Android mobile phone. For example, we can go and click on this arrow. We can see all of the different applications right here. Now this Flappy Bird right here you probably won't have, and you will see in just a few videos why I have this right here. This is not a game, this is actually a Trojan or a virus for this device. But more about that later. For now, we know that we successfully got our Android device working. You can visit Google Chrome, you can go to Images, go to Play Store, you can pretty much do anything that you like. These three buttons are the same buttons that an Android device has, so you can check out all of the tabs by clicking on this box right here. And here are all of the currently open tabs, so let's just close all of them. And we successfully got it to work. Now we are ready to start attacking this device, and we're going to start off with the first tool, which is the MSF Venom and the payload creation for the Android device. See you in the next video. Welcome back. Let's hack our Android device with the help of the Android payload that we will craft with MSF Venom. So this is going to be our first attack. We're already familiar with both MSF Console and MSF Venom, so we can go straight into hacking the target. Now, if you might be asking why am I using ZSH right here, well, I just decided to switch the terminal a little bit, and I'm going to go and use ZSH throughout this section, most of the time actually. But nonetheless, you can use the regular terminal like this, whatever you feel like. It is exactly the same, it just looks a little bit different. But nonetheless, what is important for this attack is that you have your Kali Linux machine opened and you have your Android machine open right here. So once you get both of these things open, the first thing that we want to do is, as usual, we want to check out the IP address of our Kali Linux machine. We need the IP address in order to craft the payload. Once we check it out, in my case it is 192.168.1.9, we want to generate the MSF Venom payload for the Android device. But this is something that we haven't done before. We used Meterpreter, we used Windows Reverse TCP, and all of those different payloads, but we never really saw how an Android payload looks like. Well, this is the first time, and in order to craft it, let us first navigate to the desktop, and let's run the command MSF Venom -p, and then the name of the payload, which is Android/Meterpreter/reverse_TCP. And you will already notice that this is a Meterpreter payload. So we're going to get all of those cool options that we can use in the post-exploitation with this Meterpreter Android payload. Once we set the payload, we need to set the L host, and in my case that is 192.168.1.9, and the L port can be anything, so I'm just going to go with 5555. Once I set this, I want to output it as the file that can run on Android. Android has .apk files. Those are applications that can run on Android device, so we must make sure that our payload has the extension of apk. We can call it, for example, shell, and then .apk. This is a must. If you type something like .exe or .py, it won't work. So make sure you add .apk, and once you craft the entire command, press enter. And while this payload is being created, let's go to the second terminal. I will enter ZSH, and I will go and start the Apache 2 web server, just so we can actually transfer the payload from our Kali Linux machine to the Android device. I'm going to enter my password right here, and once the Apache 2 has been started, we can go back to the first terminal. We can see the payload has been created. If I type ls, we will have it right here, which is shell.apk. And what I'm going to do right now is I'm going to move that shell.apk to the /var/www/html directory on our Kali Linux machine, because that directory is the web server directory. Permission denied. That is because this directory requires root privileges, so let's just type sudo and then move it to that directory. If I go there, type ls, we're going to have our shell.apk there. Now that we have that ready, let's go and start MSF console. While it is starting, we're going to go to our Android device, and here is where it gets tricky a little bit. As I mentioned in the theory video, there are a lot of things that the target has to do in order for this payload to be executed. The first thing that they have to do is they actually have to visit your link where your payload is. In our case, or in my case, it is under the IP address of 192.168.1.9. So I'm going to visit that payload, and we're going to see this shell.apk right here. If they click on that, the download will finish, and then they have to click on open. Now, this can only be achieved if your target, for example, thinks that the payload is something that they want to download. In other words, if they suspect of the payload being anything else but the thing that they want to download, this will most likely fail and they will never download your application and run it. Especially once they reach this part right here. If they actually read what this application will be able to do, it tells us that it will get access to modifying system settings, take pictures and videos, modify your contacts, record audio, directly call phone numbers, read call logs, read phone status and identity, and write call logs. And this is not the only thing. If we click on next, it gives us even more things that this application will be able to do, which is read your text messages, receive text messages, modify or delete contents of your SD card. And none application should be able to do all of these things. However, most of them will not read through this. They will just click on install. The application will take a few seconds to install, and it will tell you that this app was built for an older version of Android and doesn't include the latest privacy protections. If they click on install anyway, the app will fully be installed. They might get this warning right here. It depends on the Android version. It says PlayProtect hasn't seen this app before. To protect yourself and others, send it for a security scan. They will most likely, if they came up to this point, they will not send anything for the scan, and they will just run the application. But before we actually run it, we need to set up a listener inside of our MSF console. So let's go and type use exploit multi-handler, and let's set the payload to be Android Meterpreter reverse TCP. We need to set the L host to be 192.168.1.9 and set L port to be 5555. Once we do all of that, we can press run, and while our listener is being executed, they can run the application, which on their screen nothing will actually happen. But if we go back to our Kali Linux machine, we have the Meterpreter session 1 opened. And if I type get user ID, I will see what is the user ID of the target. If I type help, I will see all of the available commands that I can run on the target Android device. And we can see it's not really the same as for the Windows Meterpreter shell. We have a few new things such as screen share. We have 2 fully new sections of the commands such as Android commands right here. Here we can use activity start, check root, dump call log, dump contacts, dump SMS, geolocate, hide app icon, and many other things. We can even send SMS. However, if you try any of these commands in an actual virtual machine, of course they will not work because we cannot send an SMS from a virtual machine. But if you were to hack an actual Android device, you can type send SMS, then -d, and as it says right here, -d specifies the destination address. In our case, that should be a phone number. So you specify the phone number that you want to send this to. It can be anything. And -t is the actual text that you want to send. It must be a text between the double quotes, and you can type anything such as hello world. Of course, this won't work because our target is an actual virtual machine, but if you were to once again hack an actual Android device, this will send a text message to this phone number with this hello world message. Cool, right? And that is just one of the commands that you can do. You can dump all of the SMS messages. If you type dump_SMS, this will print out all of the messages that that target has stored. So you can see what the target has talked with other people. You can even go and try to dump contacts in order to get all of the contacts from their phone. You can dump call logs to see all of the people that they actually had a voice call with. There are other cool options as well, such as VLAN geolocate, and it says get current lat long using LAN information. And this lat long is simply just latitude and longitude. In the application controller commands, what you can do is you can install different applications. You can list applications. If I type app_list, for some reason this time it will time out. But nonetheless, that could be because of this send SMS message. We're going to check out this app list in the next video once we try out different attack. But one more thing I want to show you before I close off with this video is that actual place where your application got installed. If I just close this Google Chrome first, is if you go to the applications, which you can go to by clicking on this arrow right here, you will have this main activity with the Android logo. And this is our payload. This is the virus that we sent to the target. In order to uninstall it, you can simply just hold on to it a little bit and then drag it to the uninstall. And this will uninstall the payload from the Android device. Just in case you're testing on a real Android device and you want to make sure that you delete it afterwards, you can do that. Nonetheless, this is our first attack on an Android device, and in the next video we're going to check out a similar attack with the Android payload just by using a different tool. And then we're also going to test out the Android application commands. See you in the next video. Welcome back. So we managed to hack the Android device in the previous video. You saw that it isn't really practical unless the target really wants to download that application, but we will leave that on the side of a social engineering. We successfully hacked it using our payload. Now we want to see a different method that we can use in order to infect the Android device. Now, to do this, there is one cool tool that we can download, which is called Evil Droid. It pretty much automates everything that we did in the previous video. For us, in case you're lazy, you can just run the Evil Droid tool and it will perform the payload creation, setting up of the server and all of that by itself. So let's see how that would work. If I go and open the Firefox and I simply just type Evil Droid in my search bar. So the first link that should pop up should be a GitHub link. We want to click on that. And as usual, we want to download this tool through GitHub. In order to do that, we're going to copy the link. And once we copy the link, we want to go to our desktop and type git clone and then the link name. Press enter. This will download the tool for us, and once it downloads, we're going to check out what are the files that we get with this tool. So let's right away change the directory to this tool and type ls. So we have the changelog, we have the actual tool right here, we have something called icons, and that is something that we're going to check out later. We have readme.md and we have the tools right here. So I'm not sure if this Evil Droid is an executable file. Let's give it a try. It says permission denied, so it might actually require root privileges in order to run. Let's try it with sudo, so sudo and then Evil Droid, enter the root password, and it will tell us command not found. Let's first try to make this an executable, and if I type ls once again, now it changed colors, so let's try to run it with sudo privileges. Once it starts, it will tell us checking for internet, it is connected, it will check for dependencies, and if there is anything or any tool that it needs, but that it couldn't find, it is going to install it by default, so you don't really have to do anything. As you can see, we're missing this AAPT and it is installing it for us. Let's wait for a few seconds in order for this to finish. And once it finishes, it should prompt you with this window right here that says Execute Framework and Services. We want to click here Yes, and this will start the Apache 2 service for us, and it will start the Postgres SQL service also for us. The Apache 2 is used in order to transfer the payload the same way that we did in the previous video, and the Postgres is used in order to load the MSF console exploits and payloads faster. Once we click on that, it will lead us to the main menu. So we have a couple options right here. We have the option to create the application or the APK file with the MSF Venom, which is MSF. We have the option to backdoor APK original with the old method and to backdoor APK original with the new method. We can bypass antivirus APK with the help of icon change, but most of the Android devices don't even have an antivirus, so you can try this on your own just to see how it would look like with payload having the icon changed. After that, we can start the listener for our payload and we can clean all of the files that we created using the C command. So what we're going to try this time is we're going to just create the regular payload. It will automatically find our IP address and it will print it right here. We want to click on OK. Keep in mind that it also gives you your public IP address in case you want to actually infect the device over WAN. But this time we are still attacking a target inside of our local area network, so I'm just going to click on OK. The port, I'm going to type it to be 5555. And I'm going to name the payload Evil APK. Let's just leave it on that and click on OK. Now the next option that it gives us is which type of payload we want to create. Keep in mind, all of these payloads are Android payloads, so you can just give it a try for each and every one of them. I'm just going to go with the regular Android Meterpreter reverse TCP, the same one that we used before. All of these others would work as well, so if you want to create another one, you can give it a try. Once you select the payload, click on OK. It will generate the payload and it will do all of these things automatically. Once it creates the payload, it will give us an update right here that the APK payload was created under this location right here. Let's click on OK. And after that, it gives us an option to choose whether we want to start the multi-handler with MSF console with the help of this tool. It will do all of these things automatically. So let's just click on OK. It will load up our multi-handler. And while it does that, what we're going to do with the help of a second terminal is we're going to navigate back to the /home/mrhacker/desktop, then change to the Evil Droid application, and here we're going to have our payload right in this directory. So let's change it to Evil APK, type ls, and here is our payload. Let's move the payload to our Apache 2 web directory, so sudo mv and then Evil APK to the var www/html. Okay, once that is done, let's go back to our Evil Droid. And here we can see that our multi-handler set up the reverse connection for us automatically. Let's go and download the payload. We do it the same way that we did in the previous video, and hopefully if we did everything correctly, we should have a connection back inside of our MSF console. Let's load the page, let's refresh the page, and here is our evil apk.apk file. Let's run it. We want to download it, open it. As usual, we want to go through the steps and install the payload on the Android device. Let's click on open. And if we go back, here is our Meterpreter connection. Now, let's give a try to the command that crashed our connection in the last video, which is app_list. And this time it actually works. We can see a list of all of the applications that are installed on this Android device. And we can also use these other commands in order to run some of the applications in order to install or uninstall a certain application. If we go and type, for example, check root, it will tell us device is rooted. But of course, this is just a virtual machine, and you can test all of these commands also on an Android device in case you have one. Nonetheless, we performed a second way of attacking the target, and in the next video, we're going to see an advanced way of tricking the user into installing our application. We're going to inject our payload into another application and make it execute that way. Welcome back. time to perform an advanced attack on an Android device. Or should I say this is more of a social engineering attack because we're tricking the target into installing an application that is infected with our payload. Remember in one of the previous videos from the Android section where I showed you that we actually had Flappy Bird application right here in the Android applications. Well, you don't see it now because I deleted it, but that application was actually infected with our payload. And I'm going to show you right now how we can do that. The first thing that you want to do is you first of all want to follow this tutorial, and in case something doesn't work, you want to run these commands. I will just type them right now, and in case you watch this entire tutorial and something doesn't work, make sure to run these 3 commands and try it again. The first command would be apt-get remove apk tool. Once again, don't run this right now, I'm just showing it to you. And after you execute this command, you would want to navigate to the Firefox, type apk tool, and from the first link, you want to click on how to install. This will lead you to the installation of apk tool, and you want to navigate to the Linux installation and follow these steps right here. Once you follow these steps and install the apk tool, then the last command that you want to run is apt-get install zip align. But we're not going to run this at the moment. We're only going to run this in case something doesn't work. So let's give it a try. Let's create a payload and infect Flappy Bird application with it. So for this to work, we're going to need an actual payload, and we're also going to need the application of Flappy Bird. Let's go with Flappy Bird first. We all know the game, most of you probably even play the game. So in order to download that, we want to be searching for the APK file. Remember, APK is something that we can run on Android. So if I type Flappy Bird APK and I search for it, I will find this link that says flappy-bird.en.updown.com. Click on that link. It will say Flappy Bird 1.3 version, and we want to download and click on this latest version right here. Click on download. It will open this window. We want to click on save file and then click on OK. Once it finishes downloading, we want to navigate to this arrow and we want to open the folder where we have our Flappy Bird APK file installed. Let's also create our payload in this directory. So open terminal here. It will open the terminal in the /downloads directory, and let me just zoom this in so you can see everything better. And once we do that, I can type ls and I will have this Flappy Bird application right here. In order to inject our payload into this, we're going to use a good old -x option from the MSF Venom, and we're going to specify the Flappy Bird APK file right here. Remember what -x means? It means that it will try to make our payload inject in this application right here. All we're left to do right now is select the payload, which is going to be the good old Meterpreter. And we want to select the lhost to be the IP address of our Kali Linux machine and lport to be any port that you want. In our case, I'm just going to use 5555 as usual. And the last option is -o, and let's just call it test.apk. Before you run it, just double check everything. You downloaded the Flappy Bird application. Make sure that it is an APK file or that it has this APK extension. You selected the correct payload. You selected the correct IP address. And once all of that is done, you can press enter right here. While this is being executed, let's go to the second terminal and start our Apache 2 web server. And let's go back, and we do get some error right here. Okay, so we got an error. What are we going to do? Let's run those 3 commands that I told you. So the first one is sudo apt-get remove apk tool. Enter the password. It even tells us apk tool is not installed. Okay, we're going to ignore this at the moment and we're going to go to the official APK site. So what does it say right here? Download Linux wrapper script. Let's go there it will open this script. Let's Control A to select everything and then copy it. Once we copy it, it will tell us the next step, which is download APK tool. But before you do that, it tells us right click and save link as APK tool. So we already copied the content of that. Let's just go and nano APK tool. Let's paste everything that we copied right here. We can save this as APK tool. And the next step is going to be download APK tool 2. Let's go find newest here. They gave us the link. And once we go right here, we want to download the newest one, which is APK tool 2.4.1. Let's click on that. Let's save the file. In just a few seconds, it should finish the download. And let's go back to check out what is the third step. So rename the downloaded jar file to apktool.jar. Let's do that. It is in our downloads directory. And it seems that we actually have 2 of these. So what I'm going to do is I'm going to remove the first one. And I'm going to rename the second one to, what did it say? Let's double check. We want to rename it to apktool.jar. So let's do that. mv apktool to the apktool.jar. Okay, great. The fourth step is move both of these files that we just downloaded and created to this location right here. And it even tells us root is needed for this. So let's enter the root account. And let's move first the APK tool to /user/local/bin. And after that, we can move the apktool.jar to /user/local/bin. Great. And the fifth step is make sure both files are executable. For this, we must navigate to that actual directory. And we want to do and type chmod +x apktool and chmod +x apktool.jar. Great. And the last step is try running apktool via command line. So if I just type apktool, awesome, it works. So another thing that you might want to give it a try is in case our payload creation still doesn't work, make sure that you're running the command as root account. Matter of fact, we're going to try to create a payload right now as root account. We're not going to go back to the regular user. And once you do that, let's go and type the same command. Once again, make sure that you're a root account. We want to type the -x option, select our APK Flappy Bird file, then -p for the payload, and lhost and lport. And at the end, -o, and let's call it test.apk. Press enter. And let's see whether it will work right now. So this command can take a few seconds to actually execute, and if we don't get any error, that means our command worked. And here it is. It finished with no errors. It went through all of these steps of unpacking the APK and setting all of the permission options for our application, and we got the payload size right here and saved as test.apk. Now, if you still got an error, try running this command as well, which is apt-get install zip-align. And after this installs, try creating the payload once again and see if it works then. But since we already got our payload right here, let's copy it or move it to /var/www/html. Once again, make sure Apache 2 is started. And if I go right here, go and visit the Google Chrome. While this opens, what I'm going to do is run MSF console. I'm going to close all of these previous tabs as we don't really need them. And let's just wait for the MSF console to open, and while it does that, let's refresh our page. Here is our test.apk, and you will notice that our payload size is significantly larger than the previous payloads that we used. And this is due to us adding this inside of a Flappy Bird. So we're not only going to run the actual payload, but we're also going to run the game Flappy Bird, and the target will have no idea that in the background they executed our Meterpreter reverse shell. Let's go and set up all of the settings right here. Use exploit multi-handler. Set payload to Android Meterpreter reverse TCP. Set lhost and set lport and run the reverse TCP handler. Great. Once it does that, we can click on the test.apk. It will ask us whether we want to download. I'm going to click on download. Open the test.apk. Go through these settings, and just a quick note. See right here that the name of the actual application is different. It's called Flappy Bird, and it has a different icon than to our previous payloads. So if the target sees this, they will think that they are downloading a regular Flappy Bird application. And let's click on install. Install anyway. And let's click first on don't send and run the application. And you will see straight away it actually went inside the Flappy Bird game. You can see it opened right here. But if we go back to Kali Linux, we got our Meterpreter session right here. And we can execute all of the commands that we were able to execute with our previous payloads. How cool is that? Our target will have no idea that they have been infected because they just opened the application that they thought they were running. Now you don't have to use Flappy Bird, you can use any other application whatsoever as long as it has .apk extension. Great, now that we did this, in the next video I will show you a way of how you can infect the target in a different network. So there is one way which is called port forwarding, but for that way you need to actually have access to your router. In case you don't have access to your router, there is a second way by using a certain tool that we will cover in the next video. But before we do that, let's give Flappy Bird a try. Let's play it once. And let's see who will have a better score. It is going a little bit slow because it is a virtual machine. Nonetheless, you can see that the game works. And I actually didn't go far, I made it only 2 points. If you do better, make sure you post it in the questions. Nonetheless, let's get straight into the next video. Hello and welcome back. All of this time, we only infected devices that were on our local network. But what if there is a person or a target in a different country that we want to infect with our payload? How can we do that? Well, we're going to see right now. As I already mentioned at the end of the previous video, there are 2 different ways. There is a way of port forwarding on a router, and I'm not going to show that right now because that would require you to have the access to the router, and every router is different, so the settings for the port forwarding could actually be completely different for you and me. But this method, which is a method using a tool called ngrok, works on any network. You do not have to have the access to your router. You can just run this tool and you can hack a device on a completely different network in a completely different country. Let's see how we can do that. So the first thing that I want you to do is I want you to open your Google Chrome and type ngrok in your search bar. Once you do that, you should see this link ngrok.com. Click on it and it will ask you to create an online account, and this is something that you must do in order for this to work. So just go on sign up, create the account, and once you create the account, it will lead you to this page right here where you will have the option to download the ngrok tool, and you will also have 3 different steps as to how you can install and run the tool. So the first step is to download the ngrok and unzip it. We want to download it for Linux as we are running Kali Linux, so I'm just going to go and save the file. Now all of these steps I already did. Once you navigate to the downloads, you will have the ngrok stable.zip file. And you will notice I have 2 of them because, as I mentioned, this is something that I already did. The next thing that you want to do is you want to move this file to your desktop and you want to run this command right here. Once you run it, you want to connect it to your account by running the command under the step number 2, And that is the entire installation. After that, you will be good to go. So let's go back to our terminal and see how ngrok works. You have this file, which you downloaded, you unzipped it, and you got this file. This is the ngrok executable. In order to run this, we can type ./ngrok, and after it, we want to specify what port we want to port forward to their servers. They work similarly as port forwarding to the router, just this time we're using their servers in order to perform the port forwarding. However, with the free version of ngrok, the port might change every time you restart the tool. If you get the paid version of ngrok, then I believe you can get a port forwarded which will be the same every time. But we're going to go with the free version right now, so we can just type dot and then /ngrok, and we want to type TCP, which stands for the connection. We want to initiate the TCP connection, and let's forward the port 5555. This is the command that we want to run in order to run ngrok. Once you do that, press enter, and it will start the tool. If it says session status online, that means everything is working. Under the account, you will see your username, which you created once creating the online account. We can see the version of ngrok, we can see the region to where it port forwarded us, and here is their server that they are using to port forward our port. This is the website or the link, and this is the port that we want our target to connect to. I know this might look confusing, but just stick with me for a moment right now. So we got our ngrok tool ready. Now let's create our payload. I will zoom this in, and I'm going to navigate to the desktop. Great. There are two things that differentiate once creating a payload for the local area network and once creating a payload for a different network with the ngrok tool. And those two things are localhost and local port that the target connects to. But before we even do that, what I want you to do is I want you to copy this link right here from the slashes up to the two dots, so 2.tcp.ngrok.io. For you this might be a different link, but I want you to copy only this part, copy selection, and I want you to run the command host and then paste this link. This host tool will give us the IP address of this link, so it tells us this link has address 3.138.45.170, and this is the IP address that you will use as a local host for your payload creation. So let's go and type msf1m-p, and for this video we don't really need to attack an Android device, we're going to attack Windows. It doesn't really matter, it will work on both of those devices. So I'm just going to go with Windows x64 meterpreter reverse TCP, and I'm using x64 because I'm attacking a 64-bit Windows. You can adapt your payload to the machine that you're attacking, and after it we set the lhost to be this IP address. Paste the selection, and the L port, remember I also said that the L port is different in this command. The L port is going to be this port right here, so 16722. For you, once again, this port will probably be different. I'm going to copy it and I'm going to paste it right here, and the output can be shell.exe. I'll press enter, and in just a few seconds we have our payload ready. Now I'm just going to go and lower both of these terminals, and I'm going to paste it, or paste the payload onto my Windows 10 desktop. Here it is. But before I run it, of course I have to set up my MSF console listener. So I'm just going to go and enter MSF console. But you will notice that as the local host and local port inside the MSF console, we're not going to be using these two things, this IP address from this link and this port right here. We only use them for our payload creation. In the MSF console, we want to specify this. We want to specify the local host to be the host that we are listening for the incoming connections, and port 5555 to be the local port that is also listening for the incoming connections. So let's go right here. First of all, we're going to use exploit multi-handler. set the payload to the payload that you generated. In case you're testing this on an Android device, make sure you select the correct payload. And the L host is going to be the IP address of 0.0.0.0, which means we're listening on any interface whatsoever. You should also select and type right here 0.0.0.0, and under the L port, you want to type the port that you forwarded. In my case, it is 5555, so I'm going to type set L port 5555. Once you do this, you want to type run. It will start listening for the connections on 0.0.0.0 on the port that you forwarded. And if I go right here and run this, for some reason it says this app cannot run on Windows. Let's see what the problem is. It could be that x64 is presenting a problem for some reason, so we're just going to create another payload real quick. It might misconfigure something once I pasted it from the Kali Linux to the desktop, but nonetheless, let's remove the current shell.exe and let's run the previous command real fast. First thing is I need an IP address from this link right here, so I'm just going to copy it once again, and I'm going to type host and then paste this. Okay, once we get the IP address, then we want to create a payload, so msfvenom-p, and let's just use the regular Meterpreter payload, which I don't believe this was an issue, but just in case, let's go with the regular payload. lhost is going to be equal to this IP address. lport is going to be equal to 167.722, which, remember, it is this port number right here. And let's also add -f to be an exe, just so we can specify that this is an exe file. For some reason, maybe this presented us a problem once we copied it to the desktop. And the output is going to be test.exe. And let's just wait for this to finish. Okay, now it gives a different size. It could be that it was a problem because I didn't specify -f exe. Nonetheless, let's go and copy the payload onto the desktop. Let's go and open the MSF console and let's run the Trojan. Go back to Kali Linux and here it is. We got the Meterpreter session 1 opened from the local host on the target machine. But it does tell us right here that Meterpreter session 1 died, and that is because we actually misconfigured the payload right here, since we set it up for the previous payload that didn't work. Therefore, it has this x64. Just so we can make sure everything works, I'm going to set the payload to be Windows Meterpreter reverse TCP. Show options. Everything else is already set. Let's run the listener once again and let's run the payload once again. And right now everything works. We got the Meterpreter session 2 opened and we can run all of the commands that our Meterpreter gives us. Awesome. Now this attack will work on any device in the world because they're not really connecting straight to our machine. They're connecting to this link right here and to this port. And what ngrok is doing for us is it is forwarding their connection back to our machine on the local host and on this port. That's why in the MSF console we're listening on this port and on the local host, while in the payload creation we specified that the target should connect right here. Then they forward the connection and we get our Meterpreter session opened. And from there we can execute all of the commands as usual. Awesome. Now let me know if you also want me to show you the port forwarding, how it looks on my router, in case you want to see that. But nonetheless, this is the best way that you can actually perform port forwarding without needing an access to the router. Thank you for watching and I will see you in the next video. Welcome back. This is a brand new introduction to anonymity bonus section that we just added to the course. This was heavily requested by a lot of students, and in here we're going to introduce ourselves to the basic steps used to anonymize ourselves on the internet. Now, since this is an ethical hacking course and our focus is on using different tools and learning the process of penetration test, in that sense, we're not going to be only covering this section as a standalone one, but actually we will try to tie it to the course in certain videos. How are we going to do that? Well, we're going to take a look at anonymity for both personal use, in case you just want to be more private when browsing the internet or doing your usual daily tasks, but we're also going to take a look at anonymity while hacking or while performing penetration tests. This will mostly focus on using different tools with VPN or using them through a proxy in order to hide ourselves better during our attacks. Usually, many tools have proxy option that allows our, for example, scans to go through a third party before reaching the target, making the target essentially not know where the scans or attacks are coming from. Why is this required? Well, some clients might ask you to perform the penetration test anonymously. Maybe they want to see if they will be able to trace you back during your penetration tests. On the other hand, if you just want to anonymize yourself for private reasons due to, for example, not wanting to be tracked by a certain website, certain company, or certain malicious people, we will cover that as well. For example, did you know that using a browser like Google Chrome provides almost no privacy or anonymity at all? Certain browsers and programs collect your data in order to better show you ads, or that is at least what they say the reason is. We will show some alternative browsers that we can use to increase our privacy and anonymity. Besides that, on our hacking site, as we already mentioned, it will help us make us more anonymous during our penetration tests. For example, this is what a normal scan that we did in the scanning section looks like. Our IP address is, for example, 111.22.33 and .44, and we are directly scanning the target. The target would then know where these scans are coming from. But if we, for example, use something like a proxy, then our scans are not directly going to the target. Therefore, the target itself will think that our scans are coming from a different IP address, which will be an IP of our proxy or of our middle source. This principle is rather the same for personal use. It's just that in personal use we're not performing scans, but we are rather doing something like visiting a website. We don't want to do it directly, but rather with the help of something like a VPN or proxy as well, so the endpoint website really doesn't know where we are connecting from. In that sense, we acquired anonymity. And to do all of this for both personal and hacking use, we're going to cover three main things. These things are VPNs, Tor browser, and proxies. You probably already heard of all three of them, but if you didn't, don't worry. We will be devoting a lecture to each one of them to see how we can use it and why does it help us in privacy and anonymity. Let's start first of all with Tor browser in the next lecture. Welcome back. Let's start off with Tor browser, the browser that we will use for anonymity. Now, Tor browser is a browser that allows us to have maximum anonymity and privacy. It is also a browser used to access deep or dark web, which you most likely have heard of since you joined this course. Now, we're not going to be touching on a subject on visiting deep web or dark web. You can take a look at the internet for that. However, you will use Tor browser to do that, but right now we want to see how we can install it and how exactly does it anonymize ourselves while visiting different websites on the internet. Well, before we even get to downloading it, in theory what it does is it changes our IP address after a certain amount of time. So, as we already mentioned in the theory video, to the website that we visit, it will appear as if we are connecting from a different physical location. Let me show you how that looks like. Before we even get to opening Tor browser, let's first of all install it. To install Tor browser, we first of all want to perform sudo apt update to update our system, and it will ask us for the password. This shouldn't take too long to finish. It should update in just a second, and right after this is finished, we're going to run the command to install the Tor browser. Okay, so our repository update has finished, and the command that we use to install the Tor browser is this one: sudo apt-get install Tor and then space Tor browser launcher. Now, the first thing that we're installing is the Tor service, while the second thing is the browser itself. If you press enter, this command will start installing the Tor browser for you. Now, since I already have it installed, I'm not going to be running this. However, you just press enter, click Y so that it installs everything, and in a few minutes this should be done and you should have it installed. As soon as this command finishes working, in order to run the Tor browser, we type Tor browser-launcher. This will start the Tor browser, but if you are running it for the first time, it will actually download the browser itself first. So just by running this command, it will open a small download window, which will take a few seconds or minutes to finish, and as soon as that's done, it should automatically start the Tor browser for you. As you can see, it started the Tor browser for me, and this is the window that you should get once you accomplish all of these commands and you fully download the Tor browser. Now, since this is quite a small screen, let me enlarge this and zoom this in a little bit, just so we can see everything better. And this is the question that will pop up first: connect to Tor. And here it gives the explanation why it asks for your permission to do this. Tor browser routes your traffic over the Tor network, run by thousands of volunteers around the world. So this is essentially how it is hiding your traffic. When you try to visit a website, whether that being a website on deep web or not, it will route your traffic through the Tor network, which will go through a bunch of different servers before reaching its endpoint, essentially making the endpoint not really know where your connection is coming from. We want to connect. Now, if you want to check this, that is completely up to you. I'll just click on connect. And it will open this page for me and for you as well. Let's also enlarge this. We can see that the search engine is DuckDuckGo, also a private search engine. And how we can check whether Tor project or Tor service is being ran, we can type in this link in our search bar. So check.torproject.org. Press enter, and this will check whether Tor is running on our machine. Now you will notice that it takes some time for pages to load, and that is because our traffic is getting routed through multiple points before reaching the destination, and that is making it slow. As we can see, this page says, "Congratulations, this browser is configured to use Tor. Your IP address appears to be this one." Now this, as you might have guessed, is not my real IP address. This is the IP address that we got from Tor browser itself. So this will appear to the endpoints that we're connecting from this IP, and we can check it by typing "what is my IP?" Once again, it will take some time to load. It will not be as fast as regular browsers. And once it loads, we want to visit any of these websites. Let's go this one. What is my IP address? And here it is. It's currently this one. And you will notice these IP addresses change from time to time. Let me just close this. This will appear to be my IPv4 address. And probably in a few minutes this will also change. Currently, my physical location is in Nigeria. The exact city is this one. And as you might have guessed, I'm nowhere near this physical location, so Tor browser is doing a good job on masking where I'm coming from. And just to mention it one more time, this is the information that the websites that you visit will also see. Nonetheless, if you're interested, you can also take a look at some other options that Tor browser has by going to Preferences, going to Privacy and Security, and you can check the options here to match your needs and your privacy level. For example, here we have the security level, and we have 3 options: Standard, Safer, and Safest. Ideally, you want to have Safer to be able to browse the internet normally and also to have some protection. Safest will break some websites since it disables JavaScript completely. It also disables some fonts and a bunch of other things as well that might break some web pages. All in all, this is pretty much the Tor browser, but we're not done with the Tor itself yet. We're going to use the Tor service in the next video to perform our Nmap scans through a proxy. We want to see how we can use our tools that we covered in the ethical hacking course and make them more anonymous while performing their action. We're going to take a look at the example of Nmap scan, which will be routed through a proxy with the help of Tor service in order to mask where the scan is coming from, but more about that in the next video. Before I finish this video off, I just want to mention one more thing, and that is that an alternative option to the Tor browser would be a browser called Brave browser. Now, you probably haven't heard of it since it's not that known, but this is a really good browser. Let me just type it in so I can show you where you can download it from. Brave browser has really good security and privacy, and in its settings it has a bunch of different options that allow you to set the privacy level to your own needs and also to make you more anonymous on the internet. So this is the page where you can download the Brave from, and it's just a recommendation. If you want to use it, feel free to use it. The choice is completely yours. Nonetheless, let's get straight into next video where we are going to take a look at running Nmap through a proxy. Welcome back. In the last video, we talked about using Tor browser to anonymize our traffic on the internet. Right now, let's take a look at how we can use something called proxy to redirect our Nmap scans through a third party in order to mask our original physical address and IP address to the target that we are scanning. So, in order to do that, what you want to do is you want to start your terminal first. And the first thing that we want to redo, in case you haven't done it in the previous lecture, is to run sudo apt-get install Tor. It will ask you for your password, and once you type the password in, it will install the Tor service for you. In case you have already done this in the previous lecture, the next command that we want to do is we want to actually start the Tor service, and we can do it with the help of this command right here. Service Tor start. Press enter. And you won't get any output back for this command. It will only ask for password, which we have to type in, and the Tor service will be started. We can check it by typing service Tor status, and it will say that the status is active. Next thing we want to do is we want to install Proxy Chains, which is a tool that will allow us to filter our traffic through a proxy. And in this specific video, we're going to filter it using the Tor service, so our IP address will change with the help of Tor service. To install Proxy Chains, you run this command, sudo apt-get install proxy chains. For me, I have already installed Proxy Chains. For you, it might take a minute or two to finish, and as soon as it's done, we want to navigate to its configuration file to set an option or two. To do that, we want to type sudo nano@c/proxychains.conf, which is short for configuration. It will open this file, and the settings that you want to have are these ones. You want to hash the strict chain or comment it out, and you want to enable the dynamic chain. Down here, we also want to add SOCKS 5 support, which will be filtered through the local host on port 9050. Even here it says defaults set to Tor. We have SOCKS 4 on localhost 9050 and SOCKS 5 on localhost 9050. Once you have all of these options set, you want to save the configuration file, exit the configuration file, and just small quick tip, make sure you use sudo once changing the configuration file, because otherwise it will not work. You won't have the permission to change this configuration file if you don't use sudo. Now, to make sure all of it works, let's try to run proxy chains, and then let's, for example, open Firefox. If this works, then we should have a stable internet connection, which will be a little bit slower in Firefox, and also our IP address should change. Pretty much the same thing that we did with Tor, but right now it should also do it in Firefox. Let's first of all try to access google.com, just to see whether we can load it. And you notice it does take some time to finish. And next thing we want to do is type, what is my IP? We just want to make sure that we successfully masked our IP address. So currently we have this IP address. You can already see that my results are given in different language, which is always a good sign. And if I go on whatismyip.com, we should see where exactly is this IP address located. Here it is. This is the location of the IP. And let's take a look at one more result. And you notice it does take quite some time for pages to load, but this is quite normal since our traffic is going through a proxy. And for some reason this timed out. Never mind, we already checked on one site and we successfully changed our IP address so it will appear like this to any website that we visit. Now that we confirmed that this works, we can close Firefox, which will automatically close this command and give us our terminal back. And now to run the nmap scan, all you have to do is simply type proxy chains and then nmap. And for example, let's go with nmap.org. We want to scan it. Let's use -f command. We already know what it does. And the scan will run. Now, one thing about this is that the scans will run much slower than without proxy chains, which is also normal. Same way our traffic is slower when we go on Firefox and when we go on Tor browser, the same reason is behind the slow nmap scan. As you can see, it already scanned a couple of ports. It found the port 80 to be open. For port 139 we got socket error or timeout, and it will do this for each and every port. And nmap.org won't really know where our traffic is coming from. Nonetheless, we got all of this to work well. We also found port 22 to be open, which is, I believe, correct result. And that is pretty much it. It's as simple as that. Now you can combine different options with the nmap scan. All of those options that we already covered, feel free to use them. Now, nmap.org is allowed to be scanned, but don't scan it multiple times. They say it on their website that you shouldn't spam scans on their website. You can scan it once or twice. that would be about it for this video. This is how we can combine proxy, Tor servers, and our Nmap scan the same way we would combine these proxy chains with other tools as well that support it. Nonetheless, thank you for watching this video, and in the next video we're going to take a look at how we can run VPN inside of Kali Linux. See you in the next lecture. Welcome back. So for now we covered Tor browser and we covered using proxy with a combination of different tools such as opening browser like Firefox with proxy chains and running Nmap scan with proxy chains. Right now, let's also see how we can install VPN inside of Kali Linux. Now, this is completely optional. You can choose whichever VPN you want. You don't have to install it and use it on Linux. You can use it on Windows, on Mac OS, and whichever VPN you choose, that's fine. For the purposes of this tutorial, we're going to take a look at using OpenVPN. So in order to run it in Kali Linux, we first of all must install it. And to install it, we run this command: sudo apt-get install OpenVPN. Press enter, it will ask for the password, and I have already downloaded this, but if you haven't, or if you don't have it in your Kali, run this command and in just a few seconds it should finish. As soon as that's done, we want to navigate to a certain website, and that website is called vpnbook.com. Type in vpnbook.com and it should open a page like this. And let me zoom this in just a little bit so we can see everything better. If we scroll down here, we are going to see different configuration files. It will say free OpenVPN. Choose your preferred VPN type below for access details. No registration or sign up is required. Since we installed OpenVPN, we want to click on OpenVPN, and you pretty much want to download any of these files. I'm personally going to go with this one, and I'm going to save this file. Click on OK, and that's about it. Now don't close this page, you can minimize it, but before you do that, open this folder, then minimize this page, and you will notice that I already have the VPN file. That is because I already tested this out, and all you want to do is right click on this and extract here. Now, once it extracts the file, it will create a folder like this, which when you open, you get the OVPN file types. And once these files are extracted, what you want to do is you want to navigate to this icon right here, click on VPN connections, and then add a VPN connection. Here you want to click on this arrow and it will open a bunch of different options, which you most likely might think that we want to go with OpenVPN since that is the one that we downloaded, but we actually want to import a saved VPN configuration. Click on that and click on create. It will open this window, so it asks us to find the file where our VPN configuration is. We just downloaded it. Find the place where you downloaded it. It's probably going to be in the downloads directory. Navigate here and I'm going to choose VPNbook TCP80. Double click on that. And now it will open the configuration window for the VPN. Now you will notice these fields right here, username and password. Now navigate back to the website that we downloaded the file from, and down here you will have the username and the password. We want to type this in. So in the username field, I'm typing VPNbook, and the password is going to be the given password. Click on save. Now if I go back to this icon, click on VPN connections, I will have VPNbook right here. I want to check it. It will take some time for it to finish. And you will notice that once you type ivconfig, you will get an extra interface with a different IP address. Now, what we also want to check is whether the IP address changed inside of our Firefox. Let's type in what is my IP. And this is the current IP address. The results are already in a different language, so we successfully changed the IP. And that is how you can install VPN in Kali Linux and use it to mask your identity and to mask your IP address to any source that you visit. But it is always a good combination to use sometimes Tor, sometimes different proxies, and sometimes VPN. All of these things are well known and they will make you anonymous, but let's also take a look at whether we can find some additional tools on GitHub that might provide even more anonymity for us. See you in the next video. Welcome back. We covered all the important things when it comes to anonymity on the internet. We covered Tor browser, the anonymous browser, and the browser that allows us to visit deep web. We covered how we can use proxies with different tools, and we also saw how we can install VPN inside of our Kali Linux and use that as well to hide our location and IP address. But we as hackers also want to discover any new tools that might help us automate this process so we don't have to bother doing all of these installations anymore. Perhaps tools like this already exist. Now, there is one tool on GitHub that we can check out, which is called Who Am I? And we can just type GitHub. Now, besides this tool, of course, there are other tools as well. This is not the only tool that you can use for anonymity. You can use whichever tool you wish. We can click on this first link right here. And this is the tool that we want. As we can see, this tool is actually in the development, so it's not fully ready, so some options might not work. And we already know that since with a lot of tools on GitHub, some options might not work, or they may be broken, or they're currently waiting for an update. Here you can read about the project. The purpose of the Who Am I tool makes you as anonymous as possible on Kali Linux. It is user-friendly with its ease of use and simple interface. It follows two different paths to ensure the highest possible level of anonymity. Finally, don't forget that there is never 100% security on the internet, which is 100% true. Down here we can take a look at different features. So we have anti-man-in-the-middle feature, log killer, IP changer, DNS changer, and many others as well. So let's take a look at this tool. We want to go to the part where it says getting started and installation. And here are some of the dependencies that we might need. So let's copy the command and install it real quick. Oops, it seems that I've copied a little bit more than just the command. So let's delete this and let's also delete this. Press enter. It will ask us for the password since this is a sudo command, and the first thing that it will perform is sudo apt update, and right after that it will install some of the additional tools and libraries that it needs in order to run this tool. So let's wait for a couple seconds for this to finish. Okay, here it is. The command has finally finished, and now let's proceed to actually install the tool. Here are the steps. First, we git clone the repository. Let me just clear the screen. Paste the command. And let's git clone this tool. Once that's done, we want to navigate to the tool directory, which is right here, Kali-Whoami. And here we want to run sudo make install. Copy that command as well. Go right here and paste it into the terminal. It will finish relatively fast, and right now our tool should be ready to run. Let's type ls to see what files we have right here, and to actually use the tool, here we can take a look at the help menu. After completing setup, run the application by typing Kali who am I in the search menu, or by typing sudo kali who am I -- help in a terminal. So let's try like that. Apparently this requires sudo privileges, so let's type it like this. Sudo kali who am I, and then -- help. Okay, so here are our options. We can either start it, stop, check the status, fix, and run this help menu again. We want to start the tool. Once the tool has been started, it will open something like a console for the tool, and it will list out all of these options right here. So we're not going to be checking all of this, but let's check some of them just for the purposes of the tutorial. Let's go, for example, with the most obvious one, which is the IP changer. If I type option number 3, it says IP changer was checked, and if I type enter once again, it will say IP changer successfully enabled. Now, let's see if that option works. If I go and type what is my IP, it is loading for quite some time, which could mean that we are filtering traffic through a proxy, and I would say that's true because it says our systems have detected unusual traffic from your computer. This page checks to see if it's really you sending the requests. We get the IP address, and sometimes this can happen if you're using tools like this. So let's perform the check and let's verify. And here we get the IP address. Let's see where the IP address is located. And it seems to be giving the wrong IP. Let's just check for the page to load. This is the same page that we used once using Tor browser, if I'm not mistaken. And it has the IP from that time saved right here for some unknown reason to me. So let's actually take a look at a different website. For example, let's go with this one. And we got a different IP, which is good. It says that I'm currently in United States in Texas, which is completely wrong. I'm nowhere near there. And this option works. Awesome. Let's take a look at another option perhaps. We run the same command. We can perhaps try to run, let's say, browser anonymization. We checked that option, and browser anonymization successfully enabled. Now, I personally don't know what this option will do inside of this tool. Perhaps it will say somewhere on the page. It probably has explanation as to what each of these options do, but we're not going to be reading through that right now. Let's see whether we can check something else again. Let's try time zone changer, for example. Press enter. And it will say time zone changer successfully enabled, but once again, we can't really check that since it doesn't give us any output back. And all the other options, feel free to take a look at them. You can also use MAC changer, DNS changer. You can run the anti-man in the middle option, and all the other things that this tool offers. Now, once again, this is just one of the tools in the sea of bunch of other tools that you can take a look at, whether it being a tool for anonymity, privacy, or something else. But always make sure that you're downloading the tool from a trusted source like GitHub. You don't want to be running a tool that you downloaded from some fishy website, right? Now, that would be about it. We covered introductory steps to anonymity, and right now that you know how to use all of the things that we covered, you can use them in combination to increase your anonymity to a whole another level. Thank you for watching, and I'll see you in the next lecture. Hello, and welcome back. So in this lecture, we're going to touch on a subject that we haven't covered in the course yet. For this, we're going to need the knowledge of two major things. One of those things is knowledge of Active Directory. Now, since this is out of the aspect for this course, we will not be covering what Active Directory is or how it works. So I do recommend for you to go and read about it, or just to get the basic knowledge so you can follow along through this challenge that we're going to go through in this lecture. So I recommend going onto the Microsoft website because all of the documentation and all of the definition and structure of Active Directory can be found here. You just type in Active Directory, you click on any of these links and you start reading about it. Now, this is a lot of things to read, so you don't really have to do that. You can just go and Google on some other website that gives more plain and simple explanation of Active Directory, what it is and how it works, and that should be enough for this lecture. The second thing that we need is a TryHackMe account. So in my bug bounty course, I do cover the TryHackMe platform, but for this course, I think we're encountering it for the first time. So go ahead, create an account on the TryHackMe platform. And once you create an account, there is one more thing that you should do, and that is to connect to their VPN so you can access their virtual machines that are used for practice. So for this particular lecture, we're going to cover the Active Directory Challenge. Now you can find the Active Directory Challenge at this link right here, so tryhackme.com, room, and then /Active Directory. Once you go there, you will also have a simple explanation here on how you can deploy the machine that we're going to be targeting, as well as how you can connect to their VPN. So to connect to their VPN, just follow along this small tutorial under the task number 1. And you should be connected to the OpenVPN at the end of this task. As you can see right here, I downloaded my VPN configuration file and I used sudo openvpn to open and run this configuration file. So you will need to use sudo. Once you do that, let me lower this. We no longer need this window. You should have their IP address. If you type ifconfig and scroll all the way down, there will be another interface turning up with an IP address for this VPN. Okay, awesome. Once we do that, we're ready to get started with attacking this machine. So we're strictly going to focus on completing these challenges right here that we are provided. So we're not going to mention some other different ways that certain things can be done. We just want to complete this task. So for the first task, which is setting up the machine and the VPN, there is nothing really that we need to do. But once we do that, we can just click on Start Machine, and our machine or our target machine will be started and its IP address will be shown in 1 minute. The machine expires in about 1 hour, but you can always click on Add 1 hour if you haven't finished everything, or you can just terminate the machine and restart it again. Okay, so once we finish the first task, we're ready to go on to the second task, which is setup. Now, for this, I already finished all of these things, but you will need to do it installing Impacket. So it does give you commands and the tools that you will need to install certain things that this challenge requires. So for example, you need to git clone the impacket.git and it will be stored in the /opt/impacket. Another thing that you need to do is install the requirements for the Impacket with pip3, and you need to run the setup.py file once you complete these two commands. So just follow along, read through all of this, follow along the commands that you need to execute for this challenge. And in case you encounter some issues, there is also different commands here that might work instead. And once you're done with the Impacket, you also want to install Bloodhound and Neo4j, with the command provided down below. It might require sudo, I don't really remember, but give it a try without and with sudo. If you have issues, always perform apt update and apt upgrade first and then redo the installation of these packages. Okay, once that is done, we are ready for the first real task, which is enumeration. So you will notice that right here I have some of the tasks completed, but we're just going to ignore that and we're going to pretend as if we're restarting this from the beginning. Okay, so enumeration. Welcome to Active Directory. Now, here is the introduction, and here is the part that explains why enumeration should be done first and which tools we can use to complete the enumeration part. So right here we have several questions that we need to answer, and some of them are already answered, but don't mind that at the moment. And let's go with the first task. So let's read through this real quick. Basic enumeration starts out with an Nmap scan. Nmap is a relatively complex utility that has been refined over the years to detect what ports are open on a device, what services are running, and even detect what operating system is it running. It's important to note that not all services may be detected correctly and not enumerated to its fullest potential. Despite Nmap being an overly complex utility, it cannot enumerate everything. Therefore, after an initial Nmap scan, we'll be using other utilities to help us enumerate the devices or the services running on the device. Okay, we have some notes here that will be used for later. And the three questions that we get in this part of the task is what tool will allow us to enumerate port 139 and 445. What is the NetBIOS domain name of the machine, and what invalid TLD, or TLD is also known as top level domain, do people commonly use for their Active Directory domain? Okay, so as our task told us, the first approach will be to run a simple Nmap scan, which we can do by typing Nmap, and then we just paste the IP address given to us right here and press enter. So this is the basic Nmap scan. We're not using any other options, and we'll just get several ports open. Now, based on these ports, we can already assume that this target is running an Active Directory, since we see NetBIOS, we see Kerberos, we see LDAP. All these ports can indicate an Active Directory. Now, if we want to check the versions, we already know that we can run the -sv scan. And this will deploy the versions, or this will output the versions of softwares running on these open ports. Okay, so we can see all of it right here, and here under this service on the LDAP we can already see the first answer to the third question right here, which is what invalid top-level domain do people commonly use for their Active Directory domain, and the answer is .local. We got .local right here outputted, so if you paste it here, it will be the correct answer. But before that, since this is the third question, just don't mind it at the moment. We did get the output of it in the SV scan, but let's answer the second question first. What is the NetBIOS domain name of the machine? So here we really don't get the output for that, but there are several tools that we can use to get the output. One of those tools is enum for Linux. If you just type enum for Linux and you paste the IP address, it will perform several different tasks or checks, including trying to discover the NetBIOS domain name of the machine. So it will take several seconds for it to finish. So let's wait for that. Okay, so we can Control-C this. We don't need it to run any longer. We got what we searched for. So the NetBIOS domain name we can find, or we can read it right from here. So here are the accounts on the Active Directory, and thm-ad would be the domain name. And we can also read it up here. It already got outputted to us before, which is right here. Domain name thm-ad. So if you copy this, you paste it right here, it will be the correct answer. And what tool will allow us to enumerate port 139.445? We can use enum for Linux, but it is not the only tool that can be used. This thm-ad can also be discovered with MSF console. So let me show you, there is a module, the auxiliary module, that can be used to also get the domain name once we input the target IP. So let's just wait for the MSF console to open up, and the auxiliary module that we want to use is the SMB version. We might have already used it before in the course, but right now we're going to use it for the purposes of enumerating an active directory. Okay, so the MSF console opened up and we want to go use auxiliary. We want to go scanner. First go scanner, then SMB and SMB version. So show options will give us all the input fields that we need to provide, and the only one is our hosts, which we can just paste like this. And if I type run, it should work, and in the output we should get the domain name that we are asked for in the enumeration phase. And here it is, authentication domain thm-ad. So it's also another tool that can be used to discover the domain name. Okay, awesome. Now that we covered the first part of the enumeration, now let's go to the enumerating users via Kerberos. So if you read through the Microsoft documentation that I provided you for the Active Directory, you will also encounter something called Kerberos, and we do get a little bit of a definition right here. So a whole host of other services are running, including Kerberos. Kerberos is a key authentication service within Active Directory. And after this definition, it does provide us with a little bit of a hint of how we can approach this challenge. And with this port open, and we saw the Kerberos running on an open port, we can use a tool called Kerbrute to brute force the directory of users, passwords, and even perform password spraying. And here's a little note. Several users have informed me that the latest version of Kerbrute does not contain the user enum flag in Kerbrute. If that is the case with the version you have selected, try an older version. So just a quick note right here. And enumeration. So for this challenge, we will need a modified user list and a password list, which will be used to cut down on time of enumeration of users and passwords hash cracking. All right. So 3 things we're going to need for this part of the challenge. We're going to need Kerbrute, so just click on this link, open in a different tab so you can download the tool. And you also want to download the user list and the password list, which you can also open in a different tab and download it from there. Now I've already downloaded all 3. As you can see, I have Kerbrute right here, I have the users and the password list right here. So simply just save the user list and the password list and you will get these 2 txt files. And Kerbrute tool can be downloaded from GitHub if we go right here. And here you will have the versions depending on which operating system you're running. We want Linux AMD 64, and you can download it, or you can see the download or installation process by deleting the releases and going to just the Kerbrute page or the Kerbrute official page. You could have also clicked right here probably, and here if I scroll all the way down, we will see the usage, and we will also see the installation guide, which tells us how we can install Kerbrute. Okay, again back to our challenge or to our Active Directory, and once it loads up, let's see which questions do we get in this part of the challenge. Okay, let's go down, once again enumerating, and the 3 questions are already answered, but let's see how did we come up with these solutions. And the first one is, what command with Kerbrute will allow us to enumerate valid usernames? So once you download Kerbrute, let's exit the MSF console, Yeah, this is the command to exit Python, not MSF console, so let's do it properly. We go to desktop or wherever you have your Kerberoot downloaded, and you change the directory to the Kerberoot. If you compiled it the way that is shown on the GitHub installation page, then in the dist directory, you will have all the executable files. Now I deleted the rest since the only one that we need is Kerberoot Linux AMD 64. Now to just run it, we can type /Kerberoot and just press enter. It will give us the help menu for this tool. Now it is asked what command within Kerberoot will allow us to enumerate valid usernames, and already here under the available commands we can see user enum, which will enumerate valid domain usernames via Kerberos, so we can already specify it right here without even running the command first. But let's see, since for the other two questions we will need to run that command. Let's do it like this. To run it properly, and let me just move this a little bit up. To run it properly, you want to type Kerberoot, or the executable name, and then user enum. Then -d will be the domain, as we can see right here. And we saw in the first part that the domain given, or the full domain given, is spookysec.local. Remember when we provided a .local under the first enumeration part? Well, this is the first or the full domain to our target, and we can also specify the IP address by using --dc. And we should also see that option somewhere, or is it in... Okay, here it is. --dc is the location of the domain controller to target. So if it is left blank, if it's not specified, it will look this up on or over DNS. So here essentially we want to copy the IP address and paste it right here. And since we are provided with user and password lists, we can use the user list to enumerate users. All we have to do is type in users.txt, but let me just see if it's in the same directory. It's not in the same directory, so we have to specify the full path: home Mr. Hacker, desktop, users.txt, or pretty much wherever you have it saved, just specify the full path to the users file, and if I press enter, it will output all the users that it managed to find. As we can see, valid username for James, SVC admin, and it also has something interesting right here, which we will talk about in just a second. And there are other valid usernames such as administrator, which will also be interesting later on, and the backup, which will certainly be interesting later on. So let's answer these questions right here. What notable account is discovered? These should jump at you. The first thing that we see is SVC admin, and why is it? Well, that's because it's the only one that outputted the entire hash right here for us to see. So that's the first account that is discovered, and that is notable and interesting to us. Now we will see what we can do with this hash later on, but let's specify SVC admin as an result right here. What is the other notable account that is discovered? Well, it's definitely backup, since it's not that common to see it, but administrator would also be a decent answer, because administrator is always something that we are targeting, but it is a normal account to see on Active Directory, whether it being administrator or root or anything like that. It's a must to have on Active Directory, so we're just going to go with backup as the other notable account that is discovered, since it can be interesting for us. Now, once you answer these two questions, you can close this tool, no need for it to run anymore. And in the next lecture, we're going to see how useful this will be for us in the exploitation phase of this challenge. See you in the next lecture. Okay, welcome back. Let's continue with our Attactive Directory. So what we did for now is we performed the two tasks of enumerating our Attactive Directory and gathering users via Kerberos. This is the interesting information that we found. SVC admin gave us a hash, And we also noticed an unusual backup account which had a valid username response. Okay, so now, since we answered all of these questions, let's move on to the task number 5, which is exploitation or abusing Kerberos. So here we could read the introduction. So after the enumeration of user accounts is finished, we can attempt to abuse a feature within Kerberos with an attack method called asrep roasting. Asrep roasting occurs when a user has the privilege does not require pre-authentication set. This means that the account does not need to provide valid identification before requesting a Kerberos ticket on the specified user account. Now, if you read about Active Directory in Kerberos, you will know or you will notice the term Kerberos tickets, and in this exploitation part, we are going to need a tool called Impacket that will allow us to generate this attack. So if you click on the Impacket, it will allow you to download the tool. I have already downloaded it, so I have it on my Kali Linux machine, but if you didn't, you need to download it first. The tool that we will need for this lecture is called getnpusers.py, which is a part of the Impacket, and it will be located wherever your Impacket is, /examples, and there you will see the tool. This will allow us to query asrep roastable accounts from the key distribution center. The only thing that's necessary to query accounts is a valid set of usernames, which we enumerated previously via Kerberos. Here it gives us a note that Impacket may also need us to use the Python version that is above 3.7. And since I already have that, that's good for me. We can go and proceed to the questions. So we have two user accounts that we could potentially query a ticket from. Which user account can you query a ticket from with no password? And the answer here is SVC admin, since we got the hash for it, but let's also get it with a tool provided to us by Impacket. We already got the hash from here, but if I go and change my directory to /opt/impacket/examples, and I run the Python 3 get np users, it should open the help menu. Here we have the help menu, and here we have a small example of the commands that we can run. So for example, get a TGT for a user, which is useful for us. Here is how we can do that. So get npusers.py, then we provide the domain, the full domain, to the Active Directory, and then the account that we're targeting. So let's try that. We also need to use the -no-pass option, which is described, I think, right here. For this operation, you don't need the account's password. It is, however, important to specify this -no-pass option in the script. Okay, so let's give it a try. Python 3 get npusers, and let me just clear the screen first. So Python 3 get npusers, and here we want to use our domain, which is pookiesec.local. We want to target the account. We can do that by providing the / and the account name after the domain. Then, as we were told, we can use the no-pass option, and I'll use the -dc-ip just to provide the IP address in case it can't find it on the network or over VPN. Okay, awesome. So this command should be complete, and if I run it, here it is. We got the TGT for SVC admin. The same output that we got once running the Kerberos in the previous lecture. We got the hash value of the password, and now all we need to do to get the password of the SVC admin account is to crack this hash. Now we do have the password list from the previous lecture that we downloaded, so we're going to use that to crack the password. Now you can already answer some of the questions right here. The SVC admin is answer for the first question. And looking at the hashcat example, now this is not that important, these two are not that important, but if you want to answer, the answer is Kerberos 5 asrep etype 23. And what mode is the hash? I didn't really search this, but you can give it a try to search it and paste it right here. But once again, it's not that important. What is important is for us to crack this hash. So copy the entire hash and let's go to desktop. Let's nano hash.txt and we can save it right here, paste clipboard, and we can just save the hash, right? And now you can use any tool that you want to crack this hash. The easiest one would probably be to use John, since all we need to do is specify John hash.txt -- word list, and here we specify which word list we want to use, and we want to use the one that's provided to us in this specific challenge, which is this password list.txt. And once I press enter, here it is. It managed to crack the password, and the password is management 2005, which is also the answer to the last question right here. Crack the hash with modified password list provided. What is the user account's password? The user account's password is management 2005. Okay, now this can be considered as full exploitation being over, since we managed to compromise the account. But let's see what we can do with this password that we cracked. So let's move on to the next part of the enumeration, which is right after the exploitation, and let's see what things we can do right here. So with the user's account credentials, we now have significantly more access within the domain. We can now attempt to enumerate any shares that the domain controller may be giving out. Okay, for this, to enumerate, we can use SMB client. Now, SMB client will most likely need to be used with sudo, so type sudo SMB client. With -u option, we specify the domain with the account that we want to log into. So let's specify spookysec.local. We want to use svc admin, and we want to use -l option, and -l option in the SMB client is used to list all the shares on the domain. All we need to do is specify // and then the IP address of the domain. I think we already have it copied, or no, we do have the hash copied now, so let me just recopy the domain, paste it right here, and the first thing that it will ask is for the sudo password, and then it will ask for the svc admin password. We already cracked it, and we know that the password is management 2000. Okay, so for some reason we get the anti-status login failure, so I might have typed it incorrectly. Let me just... Okay, here it is. Now it worked, and now we can see all the shares that are in this domain. So we can see there is 6 of them. We have admin, we have this backup, which once again is interesting to us. We have CIPC net logon and sysvol. And the reason why backup is interesting to us is because it's not common to be here. Others are common to be here, and backup is something that's sticking out once again. So to answer some of these questions, what utility can we use to map remote SMB shares? We already saw it's SMB client. We can provide it right here as answer. Which option we use to list the shares? So we use the -l option, and that will also be the correct answer. How many remote shares is the server listing? We counted that to be 6 right here, and there is one particular share that we have access to that contains a text file. Now, we didn't really come up to here yet, so let's see whether do we indeed have access to the backup share. Okay, so we can also once again use SMB client to access the share. So sudo SMB client, we provide -u with the domain and the account. So svc -admin, and only thing we need to do, we no longer need to use the -l option. We just need to specify the IP address and also the share that we want to access. So in our case, we want to access the backup share, which we should be able to. once entering the SVC admin password. And here if I type dir, we get one file in the directory, which is the backup credentials. Since, let me see if pwd is working. So pwd is working and the current directory is backup. So we successfully entered the backup share or the backup directory, and we have one file which is backup credentials.txt, which of course will be interesting to us. So let's use get command to get backup credentials, and we can see it is downloaded right here on the desktop. And the reason it's on the desktop is because my terminal is currently in the desktop directory, so that's where it got downloaded. Now, of course, I did not know this at the start, that we only have access to the backup account, but if you give a try to some other share that we saw, such as for example admin, and you type in the password, we will get access denied error, and the only one that doesn't get access denied error is backup account. So now that we downloaded our backup credentials, we can cat it to see the output, and the output seems weird, right? Well, you will eventually find out that this is base 64 and this can be decoded, but let's first answer the fifth question in this task, which is what is the content of the file. The content of the file is this. We just copy it and paste it right here, and we got the correct answer. Now to decode this, we can use any online decoder, so just type base64 decode, and we can use any website that pops up. Just make sure that we copy this first, go to this website. Since I already used it before, let's use it again, and let's paste this. Just zoom this in so we can see it a little bit better. And if I click on decode, okay, here it is, backup at spookysec.local, and this would be the password. So we successfully got the output or the password for the backup account after we decoded the backup credentials from base64. Now you can answer this question right here, which is decoding the contents of the file. What is the full content? You just copy the output that we got and you paste it right here. Okay, awesome. So we successfully compromised technically two accounts. We compromised the SVC admin and the backup account, or we got the backup credentials once we logged in as SVC admin, since SVC admin had access to the backup share, but it didn't have access to other shares. So there's a little bit of a vulnerability right there, since we did have access to the backup account, which provides us with backup credentials, but we cannot access any other share, which is quite contradictory, since we can just use the backup account to access other shares, which we will see in the next lecture. So we successfully compromised one account for now, and let's see how we can perform privilege escalation in the next lecture. See you there. Welcome back. Let's perform the last two steps of our challenge. So we successfully compromised the Active Directory by getting access to the SVC admin account, and towards the end of the last lecture we also saw that we can access the backup share, and we got credentials out of that share since they were stored in a file that we had an access to. Once we decoded the file content, we got the password for that account, which is right here. Now let's see how we can use that to our advantage, and let's move on to the next step, which is domain privilege escalation, elevating privileges within the domain. Okay, let's read what it says. Now that we have new user account credentials, we may have more privileges on the system than before, since if you remember, SVC admin couldn't really access anything else but the backup share. But now we got the backup account as well, so the username of the account backup gets us thinking. What is this backup account to? Well, it is the backup account for the domain controller. This account has a unique permission that allows all Active Directory changes to be synced with this user account. This includes password hashes. Knowing this, we can use another tool within InPacket called secretsdump.py. This will allow us to retrieve all of the password hashes that this user account has to offer, and exploiting this, we will effectively have full control over the Active Directory domain. Okay, awesome. So we know which tool to use. We got provided that tool in the InPacket that we downloaded at the beginning of this challenge. So the file that we want to access is secretsdump.py. Let's clear this, and my InPacket is in the op directory, and I should have secretsdump.py. And by the way, if you wonder how any of these files works, you can just nano it to read the code. We already covered Python. Now this may be a little bit more advanced compared to what we coded, since it does include classes, methods, and all of that, but nonetheless, this is Python and you should be familiar with most of the code right here. Okay. Now that we know which tool to use, let's use it with sudo, since it probably does require sudo, and let's see if it does provide anything to us once we specify -h. So we do get the help menu right here, and -dc-ip is what we want. It is the IP address of the domain controller. We want to specify it as with the previous commands, the option or the IP address of our target to connect to. So let's specify it first, paste the IP address, and after that, all we need to do is provide the backup account credentials on the domain. So spookysec.local/backup, so it's no longer svc admin, now we want to access backup, and the password is backup, and it's written right here. We can just copy it, so, or since I already typed backup, 2517860. So 2517860. All right. So we specified the secretsdump, which is the tool that we got provided with to use. We specified the IP address of our domain, and then we specified the full path or full domain with the account and its password that we want to use. Let's press enter. Okay, so we do get some error. Let's see. Why do we get the error? Remote operations failed, connection error, name or service not known. Okay, so we might need to also provide the IP address at the end. Let's try it like this. So once again, we did provide it right here, but let's also provide it in the domain. So we use the backup account at this IP address, which is once again the target's IP. And if I press enter, okay, now it works. Here we get the hash to all of the accounts on this Active Directory, and specifically we would most likely be interested in the administrator hash right here. Since with this hash we can actually use a different tool that we got told to use at the beginning of the challenge, which we will see in just a second, to access the administrator account with just this hash. Now, this entire line is not the entire hash. What we are mostly interested in, or what the NTLM hash will be, is just this third part right here, which starts with 0E. So we can just copy it, 0E, and then we can use a different tool to access the administrator account using this hash. So the tool that we want to use, let me just clear this, is evil-winrm. This tool will allow us to gain access to this Active Directory by just providing the username and the hash value. So if I type it, I will most likely need to use it with sudo, and then here I have the command autocompleted from before, but all I want to do is change the IP address because it's not the same. So this is the command, sudo evil-winrm-i I will be for the IP address of the target. Here we specify the IP, then -u, which stands for username. You want to specify the username, and then -H, where you will specify the actual hash value for that account, which we got by using the secrets dump tool. Okay, let's press enter. It might take a few seconds to work, and hopefully, if it works, we will get access to the administrator account on the domain. Here it is. If I type who am I am the thm-ad, which remember is the NetBIOS domain that we specified in the first or in the second enumeration of this machine, and then /administrator, which is our account, and we are in the administrator directory. So we successfully escalated our privileges by getting this hash, providing it to the EvilWin RM, which allowed us to actually get access to the administrator account. And now let's see why that is possible, or in other words, let's answer these questions right here. So what method allowed us to dump ntds.dit? And for anyone who's wondering what that is, let me just show you. I exited the session with the administrator. Once we ran the secrets dump with the backup account, remember we got all the hashes, but we get answer to this question somewhere towards the beginning. So here it is. Using the DRSU API method, we got ntds.dit secrets. So we can specify the method DRSU API, and what is the administrator NTLM hash. NTLM hash, we already said it's the third part, so just copy it, paste it right here, it should be correct. What method of attack could allow us to authenticate as the user without a password, which we saw 1 minute ago once we used the EvilWin RM, is the pass the hash attack. So with the pass the hash attack, or with the attack that we used right before going to answer these questions, we successfully got access to the administrator account without even knowing their password. We only had their hash, we provided a hash, and we logged in to the account with just the hash. Using a tool called EvilWin RM, which we just did, what option will allow us to use a hash? And here it's -H, and I believe that's also what we used, yeah, -H, which allowed us to pass the hash for the administrator account and get access to it like that. So let's do it once again. And let's move on to the flag submission. So flag submission is simply just finding the flag for these 3 accounts on the domain. So as we are already logged in like administrator account, we can type dir to see if there's anything in this directory. If I go back, type dir here. And if I remember correctly, the flag will be on the desktop. So let's go to the desktop directory. Here it is, root.txt. We can use the type command to type it out, root.txt. And here's the flag for the administrator account, which we can provide right here. Now you can log in as different accounts to get access to backup and SVC admin, but it is not needed. Remember, we're admin, we can access these accounts as well. So all we need to do, go back to the users directory. So we went all the way back to the users directory, and here are the users. We have the SVC admin, which is required right here. So let's get the SVC admin flag. Let's say that it might also be on the desktop, and yes, if it even says right here, they can be located on each user's desktop. So dir will tell us the name, and if we type user.txt, oh, it's user.txt.txt, here is the value or the flag. So let's copy it, paste it under the SVC admin, and we can submit it. Should be correct. And here is one more step. For the backup account, we just do the same thing. Let's see if there's backup right here. It should be. There's the backup account. Let's go to the desktop. Dir type privask.txt, and here is the flag for the backup account. We paste it right here, and it should also be correct. So we successfully completed the entire challenge of hacking or compromising the Active Directory, and also performing privilege escalation on it to gain access to the administrator account. And for the end, we provided these 3 flags which are needed. Okay, awesome. Now, in case you didn't understand some of the stuff that we covered here, it's really important what I mentioned at the beginning of the challenge to learn about Active Directory, learn about how it works, so you can fully understand this challenge. Now, this is not really a beginner challenge, but it's also not too advanced. It's somewhere in the medium, and I believe that's how it's ranked as well. I know somewhere here, yeah, here it is, the difficulty is medium, so it's not too hard, but it's also not for the beginners, because it does require knowledge of using these different tools that we covered, and also knowledge of how Active Directory works, and what type of the attacks we can perform on the Active Directory. So, play with this a little bit more. You can redo this on your own if you think that will boost your skills, but you can also cover other machines on TryHackMe platform. There are also free ones, there are paid ones, and you can cover different machines and practice your skills, whether that being attacking a different Active Directory, or whether that being performing any other type of the attack that we covered throughout the course. Nonetheless, thank you for watching, and I will see you in the next lecture. Congratulations! Our journey has come to an end. I know it wasn't easy, but you did it. You went from regular computer user to an ethical hacker with a good knowledge base. We also touched on some advanced subjects, but did you really pick up all the knowledge that you need? We can say we covered completely everything you need to become an ethical hacker, but we only covered it. It is on you to practice all of these things that we learned until you master all of it. And that part will take some time. We have covered a lot of things, from different tools to coding our own tools. We covered web vulnerabilities, network vulnerabilities, and many different things that are useful. However, you might still feel unsure about them. Don't worry. All of this will come in place with lots and lots of practice. Also, we will be updating this course with new topics frequently, so keep an eye on that as well to learn something new. Since even though all of this is enough to get you started in ethical hacking, you still have a lot to learn, and there still could be a lot of things that are unknown to you. Especially in this field, since everything moves so fast and you need to keep up with new technologies and new vulnerabilities. But this is something that you will get used to with time. There are many different paths that you can take from now and start learning something in greater details that perhaps piqued your interest inside the course. After this video, you will see a couple articles that can guide you to what to do next depending on what interests you. It could be coding your own tools, it could be getting into web app penetration testing even more, or you maybe want to learn how to create your own exploits and find new vulnerabilities. All of these is something I will mention in the article, so make sure you check them out after this video. Learning more and more will get you from an intermediate ethical hacker to master ethical hacker. Be patient and practice a lot to achieve this. Once again, if there are any further questions you might have, feel free to post them in the Q&A section and I will gladly answer them. Be wise with what you learn and happy hacking!